Hello, hello. Today we're going to work and cast again. Specifically, I want to improve the LSP. So, yeah. Because last time we added the thing that allows my code to be written in multiple files, but the language server currently treats every file as standalone one, which results in the wrong thing, basically. Which results in things being wrong. I'm going to figure out how to make it correct. Right, so here is my example. For example, a hello world, right? There is my hello world. The language server works here. One of the things that I cannot do right now is I cannot go to the definition of the things. It would be really nice if I could go to the definition here. And that would take me to the standard library. So here's my standard library, just normal cast code. We have auto-completion here and stuff. I mean, not auto-completion, like we have all the language support here, right? And then we include here the other parts of the standard library, like the IO and RNG module. And over here, we don't have, we have the issue. This doesn't compile because this file is supposed to be included. So it's supposed to technically be a part of this file. Right? And in general, I shouldn't treat the files as standalone. Because if I try over here to, for example, since I am using the stdio, yeah, I mean, I cannot go to the definition, I guess. So like if I try to find the references of this int32, oh, wait, hold on. This actually works. Look at this. So, like, I'm trying to find the references of this int32. Who is referencing int32? I am actually referencing it. So over here, we have the definition. Over here, I'm using it as the type of the int32 to string. And then in the std.rng, I'm also using it, right? So this file is being processed right now multiple times. First, when I'm processing this stdlib, I am including the file, so I am processing it, and then I am processing it as a standalone file too. So how should this work actually? Is a question. How should this actually work is a question. Yeah, and then string is being used like in the stdio, right? Yeah. So how should this work is a question. So like, should the language server look at all the files that we have, right? Should it try to detect it? Where are we? Or should we have something similar to the Dune workspace, Dune project, Dune files, you know, Camel? In Cargo, we have Cargo tomls. So like the Rust analyzer can find the workspace root and like do things there, right? Yeah, so I need to like find the set of the roots of the root files. For example, all of these examples are supposed to be the standalone files. Yeah, importing can treat the other one as a standalone, that's fine. Including is a little bit different. So I think I need to somehow construct a graph of the files. Which files are used from where? Maybe. When making LSP for my language, how should it detect dependencies between files so it doesn't treat each file as standalone? Let's see if ChatGPT is going to give me some examples. Stop. You should use Rust, of course. So dependency graph, like I said, right? So we have import or include, yes. Parse these at the AST level. Parse all the files. You cannot just lazily parse a file when it's opened. We need on the LSP startup walk the project directory. That's right. That makes sense. Extract the list of imports for each file. Now we have a basic dependency graph. Use absolute paths under the hood to avoid duplicate nodes. Like this. Yes, yes, yes. Build the graph. Use a DAG. Yep. So, okay, so the question is how should we build this graph, right? Once again. Hello, Nigel. In the OCaml world, we have the Dune files. So the build system and the LSP uses the build system is just looking for all the Dune files around. For cast, we could have something similar. Or do we just look for all of the cast files? And that's the question. When I am... So I can parse... I mean, technically I can parse all of the cast files. Yes, sure. Is that what I want to do, though? Let me think about the future a little bit. How would we want to set up the project? Should we have something similar to Dune or Cast or Cargo Toml? Or do we just do standalone files? Like, for example, a Nix. For Nix, everything is just a Nix file. Right? Including the Flake Nix. Flake Nix does have, like, this specific thing. Like, let's imagine that I'm going to have a file called, project.cast. So this is a cast file which defines a project. You know, something similar to a build Zig. Wait a second. How does Zig language server figure things out? Zig. Hold on, let me see it again. Yeah, how does Zig language server figure things out? That's a good thing to check. So in Zig, we can have a standalone file. In Zig, I can have a standalone file. In this standalone file, I will have auto-completion. Right? And stuff. So what? The language server treats this as the root? How do I import? Like over here we have source. And we have platform, right? So we switch, built-in target is Wasm, and then I import either this or that. So I can go into this file, or I can go into that file. No diagnostics found. Zig build. Yeah. Build zig. Build zigs on. Expected enum literal. Oh, they changed the format of the in this version or something, right? Enum literal just like this. Missing top level fingerprint field, suggested value. Do I even need a build zigs on? Hold on. I don't need a build zigs on, yeah. No field or member is WASM. I don't really want to like figure out the zig right now, but WASM. This was working in the previous version of zig, but now it doesn't because build zig target result. So this is a target result. Go to the definition. No, go to definition. It doesn't work. Target doesn't work. Import target zig. Oh wait, this is the target zig. Yeah, so have a target. It has the operating system. Is there something about the WASM here? A WASM. Object format is WASM. Wait, what? There is. Arch is WASM. There you go. So it's not just is WASM, it's probably like Arch result.cpu Arch is WASM. There you go. That's how you do it. And then here we do the same thing. Target CPU Arch is WASM. Here and here. Wait, what is this? Catch panic OM expected type will build lazy path. Oh, this should be lazy path. Oh my god. Are making engine the same repo across two remote servers, work laptop and personal. Would be hell without lazy git. What do you mean without lazy git? You can just use git without being lazy, right? You can also use VS Code. I like VS Code UI more than lazy git. Maybe it's maybe I just didn't like look too much into lazy git. Some of the things, like reviewing the thing, going across all the changes is easier in VS Code. I don't know. For me at least. But you can do it in the terminal without the lazy git once again, right? Anyway, Nigel, so like what I'm trying to do here again, I'm trying to improve the language server. Specifically, I have made you know, like now we have multi-file projects, multi-file cast projects. So we need LSP to be aware of the project structure. You know, it shouldn't instead of treating each file as a standalone, which is happening right now, right? This is the improvement that I'm looking into. So the question is, how should I even organize the thing? So if I look at the zig here for some reason, once again, how does zig work? Like, I do have auto-completion here, right? Which means that the language server works. Is the Zig language server aware of the entire project structure? Like, I have the auto-completion here in both the file, which is not even being compiled right now, and in the file that actually is being compiled. Do I have like what is the GLU int? Yeah, we have the GLU int too. Yeah, this works. Like, this is different than Rust, for example, already. Wait, no. What I want to try, I think, is I want to say include. Not import, but include. Is there an include in Zig? Zig include. There is at import. There is no include in Zig. Is there? Do I need an include? There is C include, that's different. Import foo Zig. And then I have a file called foo Zig. Do I not do a dot? Just that? Maybe I didn't save it. All right, let's not look into Zig. I'm too lazy to figure it out right now. Let me just think instead. So the question, once again, is how do we determine which file is the root file and which file is not? We're just going to look for all the files so we can, yeah, we can look for all the files now. I feel like I actually need to like give it the root explicitly somehow. I feel like it would be easier if it is not super automatic, but we actually give it some structure. So we will have a thing, maybe in the project root, which will be called project KS, for example. And this project KS, this is the root. So similar to a build Zig, I guess. So and then over here, I will say, what are my roots, right? What are my roots? Or something. What do we have? So maybe this file should result in what? Like in a list? In a list of things? I don't have lists yet, but we can introduce a list. Oh, we can introduce a list, yes. We can use commas. Let's just say that I have like something like this, std lib. So this is the one of the files in the root. And we will also have, you know, examples /star.ks. So like every file which is in the folder examples should be treated also as a root. Yeah. So this means that the language server will only try to parse these things. There is no core syntax t comma. Wait, what do you mean t comma? It should be just Oh, this is trailing comma. Trailing comma and comma. Yeah. If I don't do the trailing comma, there is still no syntax for comma. Yeah, so like, so first thing, I need to make sure that this works. So let's have a syntax for comma. Because I want the project definition to be written in cast itself. Why not? I don't want it to be a JSON file. So compiler core syntax, we're going to add here, comma, and we're going to add trailing comma. What's a comma? A comma is a thing. To do comma assignee, to do comma pattern, you know what I want? I want to actually have it shouldn't be rec. Maybe I should instead have let rec collect comma. So here's the thing. In the syntax rules, as you can see, we just have a comma, which is a binary operator. But what I want is I want to combine all of the fields in a single list, right? And we also have the trailing comma here, right? So I want to have a function which would be like collect to the list. I want to have a collect to the list, which takes an AST, which returns the AST list, and then I want to give it the things that, like, yeah. So I want to have like a binary thing, which is just the name, binary rule name, I think. Is a string. Yeah. I think this can be can actually go to the AST module directly. Yeah, I think this can go to the AST directly. So let's just say here, this is AST into this, and binary rule name is a string, right? Yeah, let's go. So basically, I say I'm going to match AST shape with, if it is a complex one where rule is the one with the name and everything else that I don't really care about, but well, I mean, we have in the root, yes. If it's not matching the rule, then it's going to be a single list. But if it is matching, so like over here, say when name is equal to binary rule name, right? Yeah, so now we have a rule which is a group. So this should be a binary one, right? So I should say root children should have 2 children here. So root children tuple map child expect ASD tuple unwrap 2 unwrap unnamed 2, let A and B be equal to that, right? So we have now we have the binary operator that works on A and B. And what I need to do, yeah, and like the binary operators, they can be like right associatives or left associatives, right? I mean, technically, we can like just go inside and we shouldn't really care maybe here. So I will say rule, I will just say collect list, binary rule name A. And then we're also going to collect the list in the B. And then I just concatenate the lists together and that's it. Okay. And then when I'm parsing the comma, what I want is I want to say that children is actually, so like I'm going to ignore this completely. I'm going to ignore this completely. I'm going to say that children is AST collect collect list. Wait, what? Unbound value, AST. Which ads are getting unbearable? Install the ad blocker. Hello. AST collect list. Oh, because I didn't run the LSP support. There we go. Yeah, so we have the collect list here. So children is collect list where binary rule name is going to be core comma, right? Yep, AST, and then we collect that. So children is a list of the ASTs now. So now this is easy. All right. Yeah, and then I think I'm just going to like, I think I'm just going to say comma simple. Hello, Tommy Luco. I mean, I can just say comma handle actually. Hold on. I think the easy part here is that we have module C kind AST root and that, you know, so comma, yeah, you know, trailing comma is going to be kind of similar. Right? I'm going to say that let let I don't know, AST, I don't care about this AST here probably, right? I'm just going to say children tuple unwrap single unnamed into AST child expect AST, and then I will just have this child to be done over here. Yeah, since I don't care about this. Yeah, no, I will extract a method. So let's have a comma impl is going to be f type A module C kind and AST returning A is going to be equal to all of that. So in this case, I just call comma impl with module C kind and AST. Right, I don't care about the group, that's right. And then the trailing comma will say that comma impl. We want to do the comma impl with module C kind and AST like that. There you go. So comma children, yeah, comma, yeah, we don't have the yeah, what's the children here? Yeah, we don't do that. Yeah, so we have the children, which is the list of ASTs now. Okay. This will be error span to do comma type expression. I just care about the expression here for now. So we will need to have a new type of expression. We need to have a new type of expression. An expression which is a tuple. Wait, I have an expression tuple. Wait, what? Expression tuple. Or syntax. Oh, because, okay, I did make it like in the binary operator. Okay, I used it before. Yeah, okay, that's cool. That means that I don't need to do it. So we just say that we have an expression tuple. Right? With a tuple being something, and then we initialize expression span like that. So now the tuple is going to be a tuple of expressions. So there is my children. There's my children. For now, let's say that I'm not going to have any named fields and only have the unnamed fields. So this is just going to be tuple make. Tuple make. So the list is going to be children and no named yeah, no named ones. Hello the bad cop. How you doing? So then we say that children is also children into list map. So every child is an AST. I need to compile it. So I need to say that C compile for the same kind that we already have. Compile module compile kind child. Right? So this should be a list of A, right? Yeah, and there you go. This should work. This should work. Okay, is that everything? If it is compiling, it means that it's going to work, right? So we have the project like this. Cast restart language server. There you go. This works now. So I can try to do something like this. I can try to say cast eval. I can try to say cast eval project ks, right? So have a cast project, which is a tuple of two strings, which is basically a list, right? What's the difference between a tuple and a list? There is no difference, right? Right? So now that I have all of these, I can parse the project root when I'm launching my language server, and I can get the list of files that need to be parsed. And this way we do things. Okay. All right. implement comma expression. Let's see. Can you overload comma in this language? You can use your own syntax and you can have your own meaning to the comma that way. Yes, but if you use the built-in syntax, then no, because built-in syntax is hard-coded. The core syntax. You only use languages that let me overload comma? Well, you can. It's just not called overloading, I guess, right? It's not an operator. Wait, what is the language that can overload comma? Can Bash do that? I thought Bash cannot do that. So here's my language server. And what is it doing? Is it just says that when we open a document, when we open a file, I'm going to process the file. And that is wrong. We need to not process the file. I need to instead give it like the root. So the language server, let's see, like here's the library. This over here is the library, right? So we have processing, LSP processing, and this is file state. So we are processing a file and we get the file state back. But this is wrong. This is wrong. In C++ you can, but they are taking it out. Wait, really? Wait, what? They are taking features out of C++? Does that actually happen? I thought they never take features out. Why would they do that? So there is no process file, is what I'm saying. There is no process file, is what I am saying. We should instead process something else. What should I process? Or maybe like some files should be standalone. If they are not found in the root, then they should be standalone. So process file is a thing. Process file is like updating source to be a new source, right? Yeah, I think. Because like if the file is not saved yet, we still want to have the autocompletion there, right? So I think wait, does this mean that the language server should maintain a virtual file system with all the files that I care about? I think that's what should happen, right? Because not all of the files are saved, they're not on the disk, so they should exist somewhere. They exist in the editor, but I cannot really query the editor, so we are going to maintain a virtual file system inside of the language server. Right? I think so. That would maybe make sense. And then we will have not the file state, but we would have the project state, right? So the entire project state is something, right? I need to figure out what's the root path. What is the root path? They aren't taking it out, just changing it constantly looks like, even better. All right. So project state has the root, and I will have something like initialize project, right? Initialize project is a thing which should give me the project state. Right? I'm just trying to see what the API should be. Nightmare fuel. Function call a1 comma b. Overloadable, yes. I mean, you can overload operator call. That's nice. Comma. Overloadable, yes. Operator comma b. Sure. What is this used for though? I mean, yeah. Why? What is this useful for? And why don't they allow overloading the ternary operator? I mean, there's a reason for it, right? It's probably useful, right? STL doesn't use it at all. All right, Petscop, have you ever made the language server yourself? Wait, can you make a language server for Bash? So you have auto completion and like type inference there? Type inference, you already have that in your brain. Every type is a string, right? Yeah, I mean, type inference is not very difficult to do for Bash, but... Project state. I should probably like start a new thing though completely. You know what? Yeah, let's have a new thing. The LSP. I'm going to have a project.ml like this. You know, we are going to open std and I'm going to open castutil like that, and we're going to figure out the API from scratch. So what should be the API of the language server? We should be able to initialize the project, which is going to find the project root, right? Or maybe it should maybe like the argument to the project should be what? The path to the root? You know? So it's maybe a question root, right? So it's an optional one. If it's none, then I'm going to find it automatically. Like this. You know? How can I specify the type here? Root is ring. Like, I mean path, right? Like that. Option. And this returns project state, where root is a path, right? So yeah, so over here we'll say that the project state is the root, which is root option unwrap or else find root. So what's find root? Find root. So this should basically traverse the directory structure going up until it sees the project root, right? Like similar to other things, probably. To other tools like that. So now if I have the project, then the API will be what? I will say so similar to that, we're going to update the URI with the source, right? Right, so I'm going to update source of URI, which is LSP types LSP URI with the new source code, which is string. This should not actually return anything, I think. Or maybe it should. Maybe yeah, sure. File state. Fine. Update file. It's going to be this. And what is a file state? I think file state is going to be one of the two things. It's either a standalone file, right? So this way I can have autocompletion in standalone files still, or it's part of project, right? So if it is standalone, then I will actually try to like run the compiler on it as a standalone file. But if it's part of the project, then the compiler has already been ran on the project. Part of the project, you know, and project state is project state, maybe. Like, we just reference this thing. And if it is part of the project, I need to, like, not only specify the I mean, sure, yeah, part of the project state, but also, like, but also the file state, yeah. Right. Maybe file state should just be something like this, where project is a project state optional, right? And instead of having this is one or the other. So like over here, I have calculated some stuff for the file state, right? So what do we want the file to have? All of these things that I had before, right? Probably. Probably. So we have we are trying to compiling it. We have potential errors, and then we parse it. We compile it. Right. Parser is cast parser. Compiler is cast compiler. Open cast types. All right. So this is the file state. It potentially belongs to a project. So what do we store? And the project state should hold all of the files technically, right? So we should have all of the files here, I think. And then every file, if it is part of the project, it should have dependencies, right? It should have dependencies. Maybe not. So we have find root, that's fine. Find project root. And then I will have a function which is, you know, process. So we have a update file, but I want to process project. So this will trigger like the recompilation of the entire project, right? Where we have the root, which is path. It shouldn't even be the root, which is path, actually. It should be given the whole virtual file system, right? I think that's what should happen. So we have process projects, which has the file system, which is a virtual file system. I think I will need to do that. So let's have a new folder called virtual file system. Dune library. Name is virtual file system. It depends on std. Guess util, sure. Like that. So virtual file system is team. So what do we have in the virtual file system? It's very similar to the included directory, actually, right? It's very similar to the directory. So we should have yeah, like a directory, which I guess root is a directory. Where directory is having entries, which is a string map. From the name into the entry, right? And entry is either file or directory. And file is having contents, which is string, right? Yeah, I am using this in the included directory preprocessor, which is literally the same thing, kind of. So maybe I should get rid of that. Just call it a virtual file system. Like this. So we store everything in memory. That makes sense. That's all that I need here, technically, right? And then the LSP project. So LSP should depend on the virtual file system. So virtual file system like that. We have process project root. When I initialize the LSP itself, we need to read the files from the disk into the virtual file system, actually, right? So root in this case is a path. I feel like this path should be just a string. I don't know, should it? I mean, maybe it should be path. I don't know. Maybe it should be. I'm not sure yet. So like path, the difference between path and a string is allows me to have the special, and it can be std into. Or embedding the standard library in the binary. I mean, virtual file system should just be able to read, you know. So we need to be able to read. We need to be able to read from path to the virtual file system. Yeah. So this means that I could have the virtual file system, which is the standard library. That makes sense. Shouldn't be difficult. Sure. This is function path into the root, which is read directory path, and then we have let rec read directory path is going to be equal to wait, what if it's a special one? Then it means that path that I have, right? So I'm using like the effects here to read special. No, oh, it's the contents, right? Let path is path to path as file. Option get. Option get. You know? To do. So I'm just going to say that this is a string for now, just a path. It's going to be a file. I will handle the special ones later. So read directory. This is just going to be sys read directory path. This is going to give me an array of strings, which is all of the entries. Right, so I'm going to say entries. There's this. And then I'm going to say array to list, and then we say string map of list. So we have two lists, and then we have a list map. And we have list map. This should be function entry into entry and read entry. Read entry, not entry. It should be read entry file. File name dot concat path and entry, like this. This should be path dot file. Yeah, so we have read dir, then we have a read entry. Read entry path should return entry. This over here returns directory, right? And then we will also have we'll also have read file path, and this returns the file. I will do this here and here. So read file will just say that read in channel input all of the in channel open text path channel. We say let channel be this in that input all. This is contents, and then I will say that we have contents like that, right? But we want to also have function protect, right? Where finally would be in channel close. There's close and there's close, no error. Close channel. That's how you're supposed to do it. To do the finally. So that we actually close the file. Sure. Read entry. Now that I remember this, I'm actually not closing the file when I'm doing the imports and includes, I think. Anyway, read entry. So read entry should be what? Yeah, we should say if sys is directory path, then read directory path. Then it's directory, read directory path, else it's file, read file path, right? Like that. So that's all. Now I can read the path into virtual file system. Okay. So now if I say that I want to initialize the project, so the project state should have the file system. Should I just hold on? I think I want to rename this to just VFS. Let's not call it virtual FS. Let's call it VFS. So when I initialize the project, the VFS needs to be done. So this is a path, and I will say that VFS is the VFS, which is VFS read root, right? Like that. So when I initialize, we read it. Now, and now process project. So whenever I'm updating the file, this should not just have the URI and source. We should also have the project, right? I should know what my project is. Discuss done. Can I rewrite my life in it? Not yet. I'll remerge. Project is project state. I'm trying to support multiple file projects in the language server. That's what I'm doing right now. Remarch, in case you were interested. So this LSP URI should be translated into the path inside the project, and I should update the virtual file system with this new source code. Right? So LSP URI, we have path URI. I feel like the project state actually, you know what, the project state root, maybe root should be actually like URI. What even is a URI? Hold on. What even is a URI? URI is like the thing. Uniform resource identifier. Right? That's like the normal concept. I've not worked with it much. So we have like scheme, authority, path, query, and fragment. Right? Scheme, authority, path, query, and fragment. Okay. So directories can be like maybe I should have the URIs instead of paths myself. Although I don't care about queries or fragments, probably, right? We only care about scheme. Different path. I don't know. Anyway, I feel like, so like initializing the project should actually give me what? Like, yeah, I need to... Yeah, project state is root, virtual file system, and we also have the processed. Processed project, I think. So processed project is a thing where I know for each file, like it's similar to the virtual file system structure, right? But I want to have like root. Yeah, we want to have like root. Do you want to have root? I mean, we should have roots. That's what we should have. Just roots. Right, we should just have roots. Because that's what I specify in my project file, right? I specify the list of roots that I need to parse. Specify a list of roots that I need to parse, which is a list of file states. Let's have it as a list for now, yeah. So when I initialize the project, we need to say that processed is process project VFS, and then we say processed here. So whenever I update the file, I need to update the virtual file system and then process the project again from scratch, because we're not doing the incremental LSP yet. So first thing that I need to do is I need to figure out how to update this. So what will I even do? I mean, right? What will I even do? What will I even do? It depends. If I am working in the browser, the URIs are one thing. They are like in memory or something, right? Cast lang, cast playground. Let's see here. How do I find the editor? I cannot, right? Really? Can I? I'm not saying that this is the URI there. I mean, I can open the playground and then debug it like that. And to handle the URIs properly, right? Process Monaco URI, right? There, yeah. This over here is like going to be different API then. Let's do console log URI here. Then we do npm run dev. Here's the playground. And so the URI is this. We have scheme in memory, authority model. So yeah, this is the thing, formatted. It's in memory model 1. That's our file. While if we are doing the VS Code LSP, then it's going to be the actual file. Actually, it depends, right? It actually depends, really. Let me see the CLI processing process file. How about I do this here? Log info processing LSP Yuri to string Yuri, like that. Yo, Kiki Impact, hello there, thank you for the raid. How are you guys doing? Welcome, welcome. What were you doing on your stream? Doing some lead coding?
Yeah, it's a little bit of a late stream, but
nice.
I'm still here.
Resume reviews. I wonder what you think of my resume, but I don't know. I probably wouldn't. I don't want to show it. It's empty. I never tried to make a nice resume for myself. Yeah, I don't know. Never needed to.
Done before other stuff happens.
Yeah.
What problem was I looking at before? Difficulties
I don't know. I never like really looked for a job.
Medium status is to do.
I hear myself in the background. Oh wait, hold on. I'm sorry. I opened your file. Opened your stream, and I'm on my headphones now. I should be able to hear the same as you are guys hearing. All right. So what's happening on this stream, guys? If you're interested, as you came here, I'm making my own programming language, right? And so over here you see the playground, which is working on the web. We can run some code, print hello world, and yeah. Thank you again for raiding. Go rest, sure. So yeah, what I'm working on specifically is I'm trying to make the language server, which allows me to like have this hover information and like all of the other stuff work better, which specifically means that I need to make it work with multi-file projects, because until yesterday we only had a single file programs. But now my standard library is actually the valid program. Over here, here's the standard library, right? And standard library consists of multiple like modules. It's very tiny right now, but yeah. So in this module, this over here, it says that it cannot find the string in the scope because it's thinking that this file is standalone file, but it is not standalone file. It's part of the standard library because it's just been included over here. So I need to make the language server being aware of that, so that, you know, we do all of that stuff. So I just started working on this. I don't really know what I'm doing. I'm just trying to figure it out here. But I think that we need the whole project to be stored in a virtual file system. So that's what I'm doing here. Whenever you update the source code in your code editor, we're going to update the virtual file system and then process the project again. Yeah, that way we do it. So also, because of that, we need to figure out what a project is and what are the root files. So current idea for now is just that I have the project file like this, which specifies the roots, which is the files that I need to process, and not the files that are included. So the other files are going to be included from these ones. So we have the standard library, and we have like all of the examples as standalone files. Right. So I need to make this work. Right. So project state is the root, the virtual file system, and then the process project. Project just has all of these files that I have listed there to be processed. Like this. And processing the file is this structure, which is same as I had before. So when I process a file, I try to parse it, and then I try to compile it. Yeah, and then I'm storing any errors if they happened, so that I can show it to you. All right, hold on. I need a break. Like 5 minutes. Yo, I'm back. All right, so we have the virtual file system that we will be processing. The wait, this means that I'm reading the entire root. So I'm going to read all of it, including the OCaml source code here. That's not what's supposed. I guess like not the entirety of the virtual thing of the file system needs to be read here, right? Yeah, this is going to read literally everything, including my like the renv stuff. I only need to read what I need to read. So I shouldn't be using that. I should have my own read VFS. Should have my own read VFS. So that I only read the files that are relevant. Right? Right. Project state need to be mutable. Processed. Yeah, so like this is going to be mutable. Mutable processed and mutable virtual file system. So the first question that I have is how to update the virtual file system. If I have the URI, right? If I have the URI, what even is the URI2 path? We have path authority scheme query and underscore. Path. If private win32, then slash to backslash path, else path. Path. So am I using authority here? Whoops, sorry. So if there is authority and length of the path is more than 1 and scheme is file, then we add string / authority. And then we add the path. If length is less than 3, then we just add the path. What about these lengths? Is that how URIs actually work? Length more than 1, length less than 3. And also we have like AZs. Path 0, 1, 2. So like the first 3 characters of the path. The first character is a slash. The second character is a letter, and the third character is a colon. Then we convert it to the lowercase. What does this even mean? That's weird. So we have paths, which are like slash a colon. Does this mean something? I guess that's the specification of what the URI is, right? Maybe, somehow, something. I don't know. A single character. It's like a drive. It's like a drive, probably, right? Drive C. It's like a hack for Windows, isn't it? To connect to your NAS, you use // yes, but that's not a single character. In that case, you have like the URI, which has the authority, which is like HTTP or HTTPS. No, the scheme is like HTTP or HTTPS. Authority is like the IP, and the path is the path inside. I guess the scheme could be like FTP or whatever. What does the NAS do? Whatever the scheme is there. I'm just like, what should I do in my LSP, right? Like, not all of the yeah, you know. Maybe oh wait, maybe I only care about the paths here. No, I don't only care about the paths. Like, it should be like, can I check that the URI is like a prefix of the other URI, right? I need to, yeah. I think that's what should happen actually. Right? So when I initialize the state of the language server, I need to give it where are we working, right? So like, for example, when I'm opening the VS Code, we should have the root of the workspace being passed here, right? So yeah, let's say this root is LSP URI. I think that's what it should be, right? So the root of the project is not a path. Let's just give it the LSP URI like that. You know? So and then I need to yeah, and then I need to do things. I need to be able to read. The regex for a URI is pretty interesting. There are regex here. On the wiki page? No. I mean, I don't need to work with regexes. The URI specification says the following line is the regular expression for breaking down a well-formed URI reference to its components. There we go. Unreadable. How do people even work with regexes? This is completely unreadable. Just some random symbols after another random symbol. Alright, anyway. There's a webpage that breaks it down for you. Yeah, ask ChatGPT. Yo, Zaka. You probably have made your LSP work with multiple files, right? That's what I'm trying to do here. You like regex 101? Yeah. No, I remember, but like regex 101. Yeah, like debugger here or something. We can copy paste and then it will tell us what it is. No, it will not, because that's not a correct regular expression from the specification. This regex is actually not correct. Unescape delimiter, yeah. There are different kinds of the what kind? I don't know. The kind that is specified in the specification. Yeah, there are different kinds of the regexes too, right? Different flavors a little bit. Yeah. Extended. No. Insensitive. Multi-line global. Regex flags. Single line, Unicode, ungreedy, anchored, J changed. Anyway, I don't care about regexes. They're ugly. I don't want to ever work with them. There's more than one spec for regex. Nice. So yeah, we have the root, which is URI, right? If I store this root here, I just need to be able to read the virtual file system from the URI, right? Over here. What would I even initialize the URI with? In the browser, this over here, right? So like when I initialize the language server over here in the browser, I have the in-memory, right? I have in-memory model 1. I have a single file here. Wait, hold on. First of all, Monaco editor, multi-file. Like they can have multiple things, right? Monaco editor intelligence from multiple files. You need to use a single instance of Monaco editor, and for each file you want to do this, right? Like I can switch the Monaco editor to a different file technically. We can have like multiple models supported there, right? But Monaco editor doesn't have its own virtual file system, right? So I cannot read a directory really. When I initialize this thing here, I would probably initialize just with this file specifically, right? So the root will be the file itself. So read VFS will actually we'll figure it out. I think I can see that if this URI is the in-memory one, that I'm not going to like look for things. Where the in-memory one is going to be always treated as the standalone thing. But if this is a file, then I'm going to like look for stuff. Probably. Right. So we have the root. We have the root. We have the root. We have the root. And over here, I have the project state and I have the URI that I want to update, right? So what I want is I want to check that this belongs to the project. Right? I think we need to check that this belongs to the project. Which means that we need to have like the it's one of these it actually, like, I only care. No, I don't only care about these file states, because these are just the roots, and these can have imports of the other files. Yeah, let's just say that if this URI is like child of the root URI. Maybe like that. So how do I check this? Is there like a thing here? There's compare. I don't care about compare though. I probably need to implement this myself. So let's see. Let is parent or is child. You know, parent is LSP URI, and its child, which is also LSP URI, right? And this returns a boolean, right? I need to know that this is the child. Actually, you know what? This should probably return, give me the optional like path, which is a relative path, right? I want to get relative path, child relative path from this parent to this child. So this will be giving me an optional string, maybe, right? So first of all, we need to check that the so this is the URIs. We need to check the same scheme, the same authority, right? I don't care about query and fragments. So yeah, we need to say that if parent authority is not equal to child authority, or parent scheme is not equal to child scheme, then we will return none. Else unbound field record field. What? I have given you the type. .lsp.uri.authority. Does that work? Unbound record field, lsp uri. How do I get the field? Stupid OCaml. Actually, that's... Wait, is that even an error? Can it just say none here? Yeah, no, it says unbound record field authority. Even although it is literally there. Is it like private? Oh, it's probably private. Can I go to... Yeah, this is the signature, right? We just have the T, which is equal to LSP URI T. And yeah, maybe there is like private stuff there. Can I go to declaration? So yeah, there's just type T there, right? I don't even know what it is. I cannot expect it. Fragment. Wait, what? But I want to expect it. Why do they not give me the API to inspect what a URI is? That's so wrong. I mean, we can just say the toPath, right? And like, if we do a toPath, it should still be a prefix, probably, right? Like, I don't really care about this, probably. We just say that let parent is parent LSP URI toPath, and the same for the child. And then we say, and then I just say child strip prefix, where prefix is the parent, right? And that's just my result. Maybe. It means that, yeah, child. Parent is the URI of the directory, which contains the project. Yeah. Okay, so if I when I update the file, I will say match child relative path project URI child URI with none. Then I'm going to, I think in this case, file state update file should give me the file state. Let's have a file state option here. None. Some path. Then we'll also have none here. So in this case, I want to say that let log info this is not part of project. And in this case, I say log info updated project file path. Like that. In this case, I want SP URI to there's toString and then there's toPath. What's the difference? Wait, what is the difference to string and toPath? They don't have any documentation for me. Okay, let me just try doing this. So in my actual LSP, so yeah, I'm just going to update the file and it's going to like be ignored maybe. So the language server is going to need to be initialized, right? As soon as we start it. Object self. Is there like constructors in OCaml? Can I have a constructor? Wait, let me see how this has even been done. I'm saying server is run server. Server is JSON RPC S is new LSP server. Yeah, we just say new LSP server. We have constructors in OCaml objects. Yes. In the initializer block or through parameters to the class. So we have initializer. Initializer like a static thing in the Java class, I think. This is like a static thing, and then camel objects. You see here, object-oriented imperative functional programming language. Maybe like this is the arguments. We have self. Constructor. There are several new things going on with this code. Firstly, the class contains the initializer. This is an argument of the class name. Wait, where is the initializer? The class contains initializer. Am I blind? There is no initializer here. There are several things going on in this code. Where class contains an initializer. This is the argument to the class name. Yeah. So we have a class virtual widget. Name string. Okay. Class oh yeah, so we have class LSP server with argument, right? Yeah, with argument. So we start the LSP server. I mean, I will just start it in the current working directory, right? I think that's what I will do. Because wait, or is there? No, hold on. There is the initialize. Request initialize, right? I think it should give me the path. LSP spec. So we have the initialize request. Initialize params has process ID. The process ID of the parent process that started the server. I don't know why would we need that. We have client info, the name of the client, like VS Code. Sure. We have version. We have locale, so we can localize the error messages if we really wanted to. Oh, there you go. Root URI. The root URI of the workspace. If null, is null if no folder is open. There you go. Yeah, so like that's what we need, right? So the LSP. Yeah, this should be like nullable. That's right. So we have document URI. Here, root URI. Lean all. Inherit this. Initialize. On request, initialize. We have initialize params here. It's only being used in set positional encoding. Which means that I probably need to override this method. Because otherwise it doesn't give me these params, alright. Do we need to, I need to override on request initialize this thing. In my cast LSP. We need to have method. Exclamation mark on request initialize. Which returns initialize result t. This p types initialize result. LSP types initialize params. Let's notify back. I mean, I'm just overriding, so I should be able to. Yeah, so like, wait, can I call the method of the parent implementation? Objects, override. How to call overridden method. Camel calling the overridden like super foo is not built in. It's not impossible. Name the method differently in the superclass. But I don't control the superclass. You can directly call the parent's version of a method from the child because the camel objects don't have the super like Java or Python. But here's the official weird workaround. You pass the parent object to the child class constructor and then delegate manually. What? Class virtual parent. Oh, we have inherit parent as super. And then we have super greet. Yeah, there you go. Okay, that makes sense. Maybe. Maybe. So I want to inherit this as super. And then we can do super method on request initialize. Notify back. I like that. Unbound value notify back. Like this, right? So this is how we call the super method. Okay, good. And now when I'm initializing like that, I am going to... So like in these parameters, we have a workspace... Wait, workspace folders. Because we potentially... Yeah, we have like a list of folders, right? Specification. This is different. Oh wait, no, they have workspace folders. The workspace folder is configured in the client when the server starts. This property is only available if the client supports folders. It can be null if the client... So like, they have the workspace folder, and we also have the root path. The root path is deprecated in favor of the root URI. So root URI of the workspace. Deprecated, it's in favor of the workspace folders. Okay, so this one is deprecated for this, and this one is deprecated for that. Okay, so I'm actually supposed to use the workspace folders. Okay, and workspace folder has the URI and the name. Okay, nice. Yeah, so we are going to use that. So we actually wait. So we are. I am supposed to have to work with multiple workspaces at the same time. So I think we are going to have this state. So yeah, what I have right now, I have this buffer one environment per document, right? That's what we had before. For every document that we open, I had the state of the file. But now we should have the state for every workspace folder, right? So workspaces, isn't it server capability? Wait, no, workspace folders is just deprecated. I mean, the other parts are just deprecated. You're supposed to use the workspace folders now, right? There is server capabilities, yes. But if it's, wait, hold on. What are you saying? Like, it can be null if the client supports workspace folders, but none are configured. Like you see in the initialize request, the root path is deprecated in favor of the root URI. Root URI is deprecated in favor of workspace folders. So I'm not even supposed to look at these, right? These are deprecated. You can just make a programming language. Yeah. It's not easy. Are workspace folders part of server capabilities or not? Like, this says client supports. It doesn't say anything about the server capabilities here, but server capabilities... Server capabilities... Server capabilities has the workspace symbol provider. It has the workspace folder server capabilities. The server supports workspace folder. Yeah. Supported Boolean change notifications. Yeah. What is it going to be used for, though? Just use Holy Seal, problems fixed. Oh. The Holy Seal is introducing more problems than it fixes, in my opinion, so no thanks. I think I need to have a hash table. If they are on v3, why didn't they remove deprecated stuff? So much bloat. Because of backward compatibility, right? Deprecated stuff is there for backward compatibility. It makes sense. Although when I'm reading this spec, I kind of don't really care about the deprecated stuff. I would like to have an option to have it hidden, right? So over here, I want to have a cast LSP project state, right? So the project state is like for the folder, and this is based on LSP types. LSP URI. Wait, is document URI different from the URI? It's not. It's the same thing. Unbound value hash table. Well, what do you mean? This one is bound and this one is not? Oh, this is a colon. Right, there we go. So now we have the workspace folders. Why is workspace folder an optional option? Why is this in a double option? Can I say option flatten? Workspace folders into option to sequence into sequence flat map function option using option to sequence. Can I do this? So this is going to be a sequence of a list, right? And then I'm going to say sequence flat map function using list to sequence, like that. So this is going to be just a sequence of the workspace folders. workspace folders is this. And then I'm going to workspace folders. So every workspace folder, once again. Oh my god, how do I go to the definition? Workspace folders, sequence map. Can I have hash table of sequence? Yes, I can. So can I say I just say that workspaces is equal to that? Or no. Hash table is already a mutable one. No, we don't do hash table of sequence. We do sequence iterate function. So I will have the yeah, let's just say workspace folders sequence iterate function folder into something, right? So the folder over here is the workspace folder, which has a name and has the URI, right? So I will say that workspaces hash table add to the workspaces folder URI, right? And over here we're going to have cast lsp project initialize project root, initialize project with the folder URI, like that, right? That's what I want. Folder URI unbound record, because this language is stupid. Let's give it the type description here. This is lsp types workspace root. Workspace folder. Okay, there we go. So we have init project. Label URI was omitted. Wait, did I make it labeled? URI. And this one actually should be yeah. Let's not make it optional yet. So I just initialize the project at this URI, right? There you go. Sure. I'm still going to use the old functionality too. So over here, I'm going to log info. Initializing project at lsp URI to string URI. Right? Okay. Let's see. I'm going to now. Oh yeah, and then also when the file has changed, right? This when the file has changed, we have contents. So in this case, I will want. Wait, so I have the document URI, right? But this so the LSP doesn't give me the option to figure out which workspace folder this document is from, right? It doesn't tell me which workspace is this from. Okay, it looks interesting, but I have to finish Haskell first. Is there such a thing as finishing Haskell? Haskell is nice. If you like Haskell, you should just stick with Haskell. The reason I didn't go for Haskell and went for Camel is because of the compilation times in Haskell. They are much worse. They are even worse than Rust, as I heard, at least on big projects. So I just don't want that. Oh, Camel is good enough. It's bad, but it's good enough. One of the things that I don't know how much you use Haskell, but I really don't like the lack of the type classes here. But it is a much simpler language. OCaml is a much simpler language. if you are the one who likes simplicity. What should I do? So like over here, I don't know which workspace folder this is coming from. Wait, so should my language server itself be able to have multiple projects at the same time? Maybe. Like if I'm working on them at the same time, you know? So like I don't have the project state, right? I need to have multiple roots of the project, of like workspaces, right? So like the language server should be able to handle multiple workspaces at the same time. So like workspaces is going to be the, I think just the list of URIs like that. All paths are unique resolve path to project if needed. But can you? I think in the VS Code you can open the folder which is a subfolder of another folder. So like workspaces can be nested. No. I think I can have the support for this in the LSP itself. So the workspaces will be just a list like that. So when I initialize, maybe I shouldn't call this project, but like, I don't know. So like we have a single workspace, but it has multiple roots. What I have like, what do we call the thing which is multiple workspaces? Is there like a name for it? So we have workspace folders, but the entire thing, handling nesting ones seems annoying. Yeah, maybe it doesn't really, like, it's not needed, but would be nice, right? So this is not project. This is just like the state. I feel like this is just the state. Paper window manager. I used paper window manager before I moved to Hyprland. Wait, did I? No, I didn't. Paper. It's the scrollable one. Yeah, it's the scrollable one. No, it's nice. But it didn't work for me for some reason. I don't remember. There's a better one though. I mean, this one is GNOME basically. It's an extension for GNOME. There is a standalone thing like that I saw somewhere. I don't remember the name of it though. Neri. Yeah, Neri, right? It won't work on display link devices, really? Is that like by design, or is that, did you report it? So processed. So it means that I will have not a single virtual file system, but multiple virtual file systems. So we will have workspaces. So we will have workspaces, which is going to be a list of workspaces. And we will have a workspace, which is having root, which is LSP URI. And we will have the processed. So I will handle them for now as separate projects, like this. So the state of the entire thing is just like a list of workspaces, and then every workspace has that. That makes sense probably. And then I also want to have like standalone files, which is not part of the workspace, which is how it's going to work on the web in the playground, right? So yeah, I don't say initialize, I just initialize work, I just say initialize, where workspaces is LSP URI T list, right? So we just say that workspaces is workspaces into list map initialize workspace, like that. Okay. Then we have initialize workspace. Path root, which is lsp URT. This returns workspace. So this is root. I'm going to read the VFS at the root. Root, like that. And then when I update a file, I'm going to first find the one, right? Yeah. So like I'm going to go over all of my yeah. Let's see. So I'm going to say, so this is not project, it's just going to be called state. This one is probably not like I should have a name for it. What is the name of like the multi-workspace thing? You don't need multiple virtual file systems. I mean, they are in the different routes. I mean, yeah, I guess I can have a single virtual file system. But yeah, I think I don't know. I think I'm using Cast for the next game jam. Probably not for the next one. It's not ready. I'm doing the rewrite, Mark. So even your Mandelbrot that you did, it doesn't work anymore because I'm doing the rewrite. But the next game jam, if you're talking about like the Ludum Dare, for example, which is going to be happening what in like 5 months or something, right? Or the D2 jam, which is in September, then maybe. But I don't know. I feel like that's not a lot of time still. We'll see. We'll see if I get there. Like I'm focusing on the LSP maybe a little bit too much instead of working on the language. If I worked on the language, I could get the features pretty quickly. But I want the LSP so that working and making a game in it is like not a painful experience. Right? State. Okay, so I'm going to say this here. No one knows the name for this? State. This should be workspace state, by the way. And this, let's just call it global state. You know? Just call it global state. Okay, so I'm going to say state.workspaces, and then I'm going to list find map. I want to find the one for the workspace. I want to find the one that has this URI as the child. So child relative path, where parent is workspace root and child is URI. Right? And I'm going to match this with, there you go. So yeah. No, not this actually. Let path is relative path, and then I will return workspace and the path, right? So we have a workspace, like now we have concrete workspace and path. Updated file as part of this, which is going to be lsp URI to string workspace root, like that, you know. So initialize gives me the global state. Okay. So this is CastLSP project global state. And over here, project initialize. I'm just going to initialize the workspace folders. Okay. I'm going to initialize workspace folders into list map. Into sequence, list of sequence map function workspace into workspace dot URI, like that. And the workspace is SP types for workspace folder. You have a valid package project format for every file or folder could be compiled. Yeah, like I have not for now I will have the temporary one, which is this. I'm going to have in the root of the workspaces, I'm expected to have the project.ks, which is just listing all of the roots that I need to compile. So like, you know, I need to compile all of the examples and the standard library. This is like the root of the standard library, and all of the other parts of the standard library should be ignored, right? Yeah, something like that for now. This is not the final format though, of course. But I want this format to be like also the same like cast file basically, so everything is written in the same language, even the specification of the project. Because why not, right? I think I want it to be a JSON file or something like a TOML. Yeah, so when I initialized that, so I don't have buffer, I don't have workspaces, right? I just have instead the global state here. The state, I can just say state is ref none. A state is the reference to cast lsp project global state ref, like this option, because I only initialize it when I get the request initialized, right? So over here I don't ignore this, instead I say that state is some that colonical, right? There you go. And then when I update the file over here, now that I have updated the file, we are going to say cast lsp project update file. So I'm going to update the file. This takes the this takes the global this takes the state into option get. Right, so it must be initialized here. Let's just say get state and the URI and contents, right? That's what I want. And this is the file state. I'm going to ignore this for now. So, and then the get state is going to be a method private get state is going to be equal match state with some state, then state, and if none, then I'm going to fail trying to get state before initialize, something like that. Get state, this should be like what, self get state. Okay, now let's start the thing. So here is my project. I'm going to restart cast language server, and it failed. Nice. Output of the cast language server. Error. File project ls. Oh wait, hold on. Error. File project ml. Wait, do I have the actual error? Does it not build? Don't build? No, that's not the problem. Wait, what's the problem then? I was initializing state at, yeah, so yeah, there we go. This is my workspace folder. I'm initializing the state there. Oh, this is the error. Yeah. Okay. No. That makes sense. That makes sense now. Hold on. I have some fails in my LSP project here, right? Yeah. So yeah, I initialized the workspace. Okay, I initialized the workspace. I'm initializing, so I'm trying to read the VFS there. This is failing immediately. That's what's happening. So I want to read the entire folder, but not the entire folder, right? I only want to read the files that are relevant to me. Right? Right. So only this, yeah, so I want to, and find project root is not being used actually, right? Yeah, whatever. We're going to say that the workspace is initialized here, and this is the root. Okay. Sure. So over here, I just need to read the so I want to process file, which is going to be that path is lsp URI to path. Right? I'm going to process file path. And I will have the thing process file. Process file is having path. And this should return all of these. I should like technically I should evaluate, right? So like this needs to actually interpret the file. I need to process the file, which is file name concat path and project ks, right? That's what I want. Process file. Global is global state option. Right. So this should return file state. So this is where I will do the same as I was doing before. Processing the file, like everything like that. I'm just going to say that global is none. Here, when I process it without global, how would I just say global like this? Unbound value URI. Yeah. URI and source. Okay. And have URI here, right? So this is the project KS path is that. So I want to process where global is none. But path. So it's not path, right? I need URI and I need contents. So I will say that source is contents and file name is lsp URI to path URI. Handle nested workspaces, check if it belongs to any active workspace, and it all works. All right. To path URI. Right, so URI is lsp URI. Contents is string. This file name should be file, right? Read virtual file system. I mean, I don't need to read the virtual file system, actually. I can keep the file system originally to be empty. Yeah, I can keep the file system originally to be empty. I'm just going to, like, evaluate this thing. Because, yeah. So I'm just going to actually say that root is entries is string map empty, like that. I'm just going to have the empty virtual file system, and it will only like populate it when I update the file's contents. So project KS path is this. So wait, hold on. So when I open a project for the first time, it's going to give me like the document states for all of the files that I open, and I will trigger the recompilation of the entire workspace here for every file. I mean the files that I open, but the files for which, like, I'm getting the request, right? On doc, you need to read from disk. I mean over here I will need to, but like over here, I don't know who is calling this. We have the method here on doc, right? So we have the contents here. This is implemented on doc. Yeah, so we have notification document was opened, or document was changed. Okay, so opened and changed is different thing, right? If the document was opened, I don't need to update it. Yes, this is different things. And then we have the document was closed too. Right. Yeah. I feel like over here I will also say I will say something like, you know, changed, which is like a boolean. So I will not update the file over here in my project. If it was not changed. So if changed, only then I will be updating in the workspace. Document opened closed is the old way of doing things, you think? It's horrible for renames. You get two separate events. Because it's closed and opened at the same time. All right. Yeah. I don't know. So this was just in the example of the LSP implementation for the library that I'm using. So that's how they did it here. So when I'll keep this for now. Changed is false when I just opened it, and when it changed is false. Like, should I instead handle like what? Like there should be document was renamed or something. Event, right? And that will, so I will have like the server capability which can handle the renames, and then we will not get two events or something, probably, right? I'm not going to look into that right now. Let's see, project. So project KS path is this. So now I'm going to process file project KS path. I'm going to process this file. This is the only file that I'm actually going to evaluate, I think, in the LSP. Right? Process file. Global is none. URI contents. So the URI is LSP URI of path, project KS path. And the contents, project KS contents, a read file, source read, file project KS path dot contents. How about that? So this is the process file, processed project KS is this. So this has been processed, and then I want to evaluate it. Modern good API is workspace slash did create files, workspace did rename files, workspace did delete files. Okay. I'll keep that in mind. But we can use the deprecated APIs too, right? So we have the processed. Project KS should have the compiled. I'm going to match project cast compiled with read VFS. I don't need like to read the VFS. Hold on. VFS is always going to be empty, I think. Right? But process project VFS. Yeah, process project. This needs to have like the project be the one that is like I need to like actually evaluate what's the project here. So it should be compiled. Process project of VFS. Okay. Like over here, I don't always want to give it the VFS. Sometimes it's a virtual file system, and sometimes it's an actual file system, I think. So I actually want process project to be done through the yeah, I will actually have it be done through the effect system. So effect e plus equal read read file string. How about that? Read file string into string, right? I think that's what I will do. Process project. Processed is this. Where is my syntax error? Line 82 over here. Why is this a syntax error? What's the syntax error here? There is no syntax error. Why are you lying to me? Stupido camel. Over here is the actual syntax error. Right? String into string. Effect T. I mean, I don't need this to be done through the effects, but I can have like the function here. Yeah, let's make it like more explicit, like a named argument read file, which is string into string. So I processed the cast file here, the project KS. I have processed it, which means that I have maybe compiled it. Processed. Yeah, and processed is actually going to be an optional processed project, right? Because the project KS potentially has like syntax errors, then I cannot do anything there, right? So processed is this. So process project case is this. Then I say that let expression let compiled be processed project case compiled. Right? This needs to be processed. This needs to be compiled successfully. And then if it is compiled successfully, then if it is compiled successfully, then I need to evaluate it. So I'm going to say cast interpreter evaluate cast interpreter default probably compiled. Let evaluated is that. So this is a value. Now I want evaluated to be a value. So value should be a tuple. Right, which is going to be just project roots. Yeah, I should just over here process project evald. So this process project should have the project definition. Right? This is my project definition. Like I want it to be only evaluated once. Or do I? Maybe I don't care. So maybe this all should belong into the process project. Maybe this should be processed project. Like that. But I want to basically try, and if there was any exception happened, then I will return none. Otherwise, I will return some process project like that. Process project, and process project should give me the read file, right? Yeah, so read file should be basically this is the path of the root, right? Yeah, a root, which is a path. I'm going to process project where read file is a read file. So read file when I'm initializing is going to be just is going to be function path into, I'm going to say that path is file name cat root with path, and then I will do in channel input all of the channel, where channel is input channel open text path, right, like that. And then we want to close it too, so we want to say function protect function protect this, and finally we're going to in channel close channel, like that. That's my read file. Root should have been a URI. Let's call this root path, and we have the root. Okay, that works. So process project should be read file. So I'm going to just read file project ks. There you go. No, read file is actually just doing that, right? Yeah. So I'm just going to read file project ks. Okay. Right. Right. I'm going to process file. Project ks path is, I guess, just project ks, and we over here we don't do the source read, we just do read file project ks path. That makes sense. So now I have processed ks file that should be compiled. This doesn't return an option, right? It does not return an option. Process file. So we expect this to be compiled. So I want this to be option get, and then evaluated be evaled, right? So now I have the value. Now this value needs to be a tuple. So paths project is evaled value expect tuple. Let's do that. Expect tuple. This should give me basically a value tuple. So it's a value tuple, right? Like that. Probably should be a value tuple like that, actually. Expect tuple. So this is project roots. Project roots is this dot tuple dot unnamed. Project roots is project roots tuple unnamed array to list. List map function value expect string. Yeah, just a map with expected string. So this should give me a list of strings now. Okay, and then all of these strings is the ones that we should also process, right? So when I'm processing the project, we should have roots, which is file state list. So roots is project roots. Roots is project roots, and then I map those into path. So if we have a path, we're just going to process file. Process file, lsp URI of path. Process project, read file. I feel like read file should give me not just the contents, but also the URI here. I think so. Read file. What do we have? Type read file is URI, lsp URI t, and contents as a is a string. So I don't do this. I say project ks is a read file, project ks path, project ks, like that. And then we process file, project ks URI, and project ks, just project ks. This is my read file. So process file should just take the read file. That's the argument. So I have file.URI, file URI, file contents. Maybe like that's what my source should be. So again, yeah, maybe instead of path I should have URIs everywhere. Process file. So we just process file, a read file path, right? Like this. That's all I need here. Okay, now when I read the VFS, this is not going to be used even, I think, anymore. So read file is path. Over here, we are going to so with it is contents, and then I return URI is lsp URI path and contents. That. What's wrong here? Syntax error. Let extension. What? There is no syntax error here. OCaml restart. OCaml doesn't work. The OCaml language server doesn't work anymore. What do I do about it? Reload window. Format. Okay, now it works. That was weird. Okay, so everything compiles. Everything compiles. I think I'm going to process all the files. Yeah, when I process file, it will also, yeah, it will say processing that. Okay, nice. Let's open the project here. Let's see the output of the cast language server. Okay, so I have been initializing the projects, the file state at over here. so I was processing the project KS. There is a processing file. Wait, what's processing file? It's in the CLI. Yeah. Sure. Yeah, so I have initialized the state. I initialize the state of the workspace. I have read project KS. Since I opened it, I also opened it again. Why did I process this twice here, though? That's weird. This is specifically about the project. All right. Let me try to restart the cast language server. Output. Okay, so it's going to... Yeah, there you go. So I'm initializing. I have processed the file project. And then I was processing the file standard library. And I have processed that. Let's say that I save this. Then I have processed this file again, and I say processing. Again. Why? Is this being called even? If changed, then this. Like, it should have been changed. So I should see either updated file or is not part of the state. But I'm not seeing that. Log info. Project. Thing, update. LSP URI to string URI. Restart cast language server. Output. Project KS is here. I want to save it. It says processing. Processing. STLSP and processing. Yeah, that's why. Yeah, we have this. Like, yeah, that's why we have it. Okay, that makes sense. So I'm actually not getting there. Wait, I'm not getting these requests. Why not? I do this only if changed. Oh, because changed false and changed false. That's why. So when the document changed, the change should be true. Okay. Cast restart project. Put. Okay. So if I now press space here, so now so there we go. So now I update the file project KS as part of the cast. There you go. There you go. So I think child relative path actually should be strip prefix. Prefix is parent. Prefix should be over here, parent. Concatenated with a slash, I think. By the way. Like, I want to remove the slash there. Alright. Okay, so we have that. Updated. Sure. Now I want to update the virtual file. So like this over here is the path, and I want to update the path in the virtual file system, right? And this is my source. Okay. So I am updating this. Updating this. I'm going to say VFS update in the workspace VFS. So workspace VFS is going to be updated VFS. So that path is now equal to source, right? I don't know. We can call it like write file. We can call it write file, for example. Let's see. Write file is VFS into path, which is string into the new VFS. Right. So path is like that. There we go. So then I'm going to basically say function VFS path contents, right? It's going to say write file to directory VFS root path contents. Okay. Write file to directory. Yeah, so yeah, I'm going to say over here VFS with root be equal to that. There we go. So write file to read directory is a directory into path. This is going to be a recursive. Track file to directory. So directory path contents is going to be. So we first find slash index, right? I should find the slash index, which is string index. I'm going to match index opt path slash with. So if there is none, then we just need to write the file to this directory specifically. And if it is some index, then I'm going to say that subdirectory is string sub 0 index of the path, right? And then path is string sub path index +1 string length path minus index +1. Right? And then I say directory. So yeah, I need to. And first to ensure that the directory exists. So directory is ensure subdirectory in directory. And then we say directory string map find in directory. I'm going to find the subdirectory in directory dot entries. Right? I'm going to match this with, if it is a directory subdirectory, then yeah. Anything else, we're going to say fail. Must be subdir. If it is subdirectory actually, then I'm going to say I want directory with entries Hello, Brainoid. Being string map. Ed. Oh shit, oh camel. Oh shit. Oh camel. Hello there. String map add. I want to add a subdirectory name. Subdirectory name to be directory, which is write file to directory. Subdirectory. The remaining path and entries. All the fields are explicitly listed. Yes. The expression has type string map into entry. Yeah, I need to add this to existing directory entries. Right, there we go. Okay, so now I need to ensure the subdirectory exists. Right? Let ensure subdirectory, which is directory and subdirectory. So this is going to be match string map find opt dir entries subdir in dir entries. If it is none, then I'm going to say entries is string map add subdir directory entries is string map empty. Hello, Ogma. I want to add this to directory entries. If it was some directory, then I just return the original directory. If it was some file, and we fail, expected a subdir got file, something like that. Okay, that should be good. Okay, so now I can write a file to no, I cannot because what? Because over here. So if this is if this is the final, thing, then I need to actually write the file. Yeah. So I am going to say that a return entries is string map add path on path. So like the path is now a file with contents to directory entries. That's all that I need here. Okay, there we go. So now I can write to the virtual file system, I think. So write file is used here. Unbound module VFS. You are lying to me. Oh, camel. Yeah, stop lying to me. Sheepduck, hello, hello. Okay, yeah, everything compiles. So we just update the VFS here. And now that I update the VFS, I want to basically re-evaluate the entire thing, right? So when I update the file like this, I want to say that workspace has processed, and processed should be processed. It should be called not project, but like workspace, right? Maybe not project, but workspace. Liar. What do you mean liar? Wait, what? What did I lie about? I said hi. How can you lie when you say hi? Is that possible? Workspace dot no, hold on. We want to process project. So workspace dot processed is try process project. If any exception, then none. Like that. Said it was lying to you. Oh yeah, I mean, yeah, the language that I'm like, this is OCaml. OCaml is a language which is lying to me all the time. Yeah, yeah, that's true. Okay, so I try to process the project where like the read file. So like, how do I read file here? When I update a file, I'm going to now read not from the actual file system. I'm going to read not from the actual file system, but from the virtual file system. So yeah, so read file is going to be function path into what? So I need to return the red file, which has URI and has contents, right? So contents is going to be getting from, yeah, so contents is VFS read path in the workspace VFS, right? This is read the entire like folder. Read. I feel like this should not be even done here. Let's say module to from file system struct, and because I'm not going to actually use this, instead we're going to say read file, which is VFS into path into string, right? Yeah. So this will be function VFS path into read from directory VFS root path, right? So this is going to be kind of similar to write a little bit. Track read from directory. We have directory and we have path. So I'm going to find the slash. If there is no slash, then I'm going to just say I'm going to match string map find the path in directory entries, right? And if it is none, then I'm going to fail, saying path doesn't exist. Fail raise not found. Let's do that. If we say some file contents, then I want to return contents. If it is some directory, fail directory, expected file got directory. Okay, if there is the index, we have subdir name and path like that. I don't want to ensure the subdirectory really, right? But I will string map find opt subdirectory name. So if it was some directory subdirectory, then we are going to say that I want to read from directory subdirectory the remaining path. And if it is some file, then expected directory got file. If it is none, then raise not found, whatever. Something like that. Okay, that works. So we don't say read, we say read OCaml restart, read file. From the workspace VFS, we read this path. Okay, and then what is the URI? This URI is not the URI of this file, right? This is the URI, which is going to be lsp URI from off path. But this is going to be file name concat the workspace root, which is the URI, right? I just want to like concat the LSP, yeah, the URIs, but it's like I feel like this is not exactly correct. LSP URI. So I want two path workspace root, and I want to concat that with path, right? And then like convert back to URI here. Maybe that will work like for the VS Code, but not for the browser. So try process project read file. Try some this. There you go. Okay, so I'm just going to reread the entire thing. The only problem is if I have this as a read file, right? When I'm processing the project, I'm going to do what? Like, how are the relative imports going to be handled is the question. We have project roots, and I'm going to process file, read file. Well, I mean, yeah, they are going to be handled actually correctly, probably. But only in VS Code once again. Like, because the compiler itself is not going to use this function to read the files. Let's see what happens. Okay. I mean, I cannot really like do much because this. Yeah. Now I need to actually like use this states of the file instead of the old processing. Right. So I have these file states. Yeah, and this over here, the update file should return the file state. So we have process. Yeah, we process the entire project from scratch when I update the file, and now I need to find this file in the project which is processed. Right? Yeah. 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 So how will this work? We have roots. Roots are processed. Oh, this is difficult. Maybe I don't need to give it the file state back. Maybe this should just update the file, and we have the global state. And so in order to hover a specific file, we're going to traverse the entire global state to find it there. Like we have it all stored in the state somehow, right? Right? No, like, because like the reference to the file is not going to be stored. So, like, you see, when I parse the standard library, the compiler sees include, right? So the compiler will do the including, but it's not going to store the parse state and like all of the compiled state there, right? I mean, technically include should not even give me anything. Yeah, it's just the imports, I think. It's just the imports. So whenever I import a file, we have the compiler state, and I know all of the imported files there, so we kind of have the graph in this way, right? Of what depends from what. But in order to show the information inside of the included file, I kind of still need to go from the root here. Yeah. I mean, I think what we need to do is so we have let's see, core syntax, right? We have a thing that is called include, right? So whenever I include a thing, right, I am trying to read the source here. I am trying to read the source here. And then I'm trying to parse it. And then I'm trying to parse it. And then I'm trying to compile it. But it's not always compiled into... Yeah, it's compiled into some kind, by the way. So like, not all of the files are actually expressions because of that. Like, would it be the job of the compiler to say that this file has been included? Do something with it. Maybe. Maybe it will be. So the compiler, but then the compiler needs to know what the what? Like I need a hook here. I need a hook here that the LSP would be able to handle, right? So I have compiled the included file so that I can path relative to, so path, yeah, over here, path relative to source read path. I feel like after this has done, maybe let's perform an effect. Perform. So let's say that the compiler is able to do an effect, which is file compiler included file compiler effect file included. So, and the file included, I want to give it all of the as much information as possible, right? So I will give it the path that I have included. I will give it the AST that I have parsed, and I will give it the use test driven development method. No, not much. And then the result, which is compiled. Dum, dum. Kind and result. Can I do that? So compiler. Let's see. We are going to have the effects in the compiler. The compiler can do some effects. Module effect. Struct. Show me your class diagram for this project by any chance. You're learning UML. I don't have UML. I don't do UML. UML. What? I know what a UML is, but like, I don't know why would I use it. I have like I have the dependency graph here. Here's my project. I'm making a programming language, so it's called cast, right? So here's all the different parts of it. We have the parser, the lexer, the compiler, the interpreter, the inference, formatter, highlighting, language server, all of that stuff. That's the closest thing to UML, but it's not UML, obviously. Okay, so effect, and then I'm going to say type effect t plus equal file included. So file included is going to be, can I say for all a file included into a file included effect t? Is that possible? So where a file included is like a struct with path being path, with AST being AST, and kind being compiled kind of a, and result, and like compiled, I guess, is a, which means that this needs to be specified a little bit after. Let's do it in the very end. Hello, farmer. What am I working on today? I'm trying to improve the language server so that we can work on, so that I can have the language server working for multiple files. Because previously it was treating every file as its own little project. But because of that, so like if right now I go to the standard library and like this over here, it says that it doesn't know what an int32 is. And it doesn't know it because this file is actually part of the standard library, so it should be compiled as part of it and not as a standalone file. Right? So I'm trying to make that work. That's not very simple, it looks. All right. So this is result filed. There we go. This expression has a type compiler effect file included. Wait, no. Oh, hold on. Compiler effect file included. It's file included into actually unit, right? The file has been included. It's going to be handled. I don't care about the result at all. There you go. Restart a Camel language server, so it doesn't show me fake errors anymore, please. And the thing compiles. So the thing is not going to work because this effect of the file included is going to be handled in the thing. Can I do something if the effect is not handled though? Can I, like, similarly to, yeah, like, you know, we can do like print exception, set unquote exception handler. Set uncaught exception handler. Registers the function as the handler for the uncaught exceptions. The default handler is default one. Note that function is called all the functions. Note that when function is called, all the functions registered with stdlib at exit have already been called. Because of this, you must make sure any output channel is flushed. It's not like exactly uncaught exception. It's uncaught effect, right? It's uncaught effect. I mean, I can just catch it explicitly in the main, in the cast CLI. Right? Or maybe I can. ChatGPT. Can I specify default handler for effect camel? No. You have to explicitly handle every effect where it's used. There's no global effect handler registry. Wrap your effect to code in a function that always provides the same handler. Okay. So I'm just going to go to the main source cast bin main over here, right? So I'm going to say try, and I'm going to say with effect cast compiler don't I just include the compiler here? As a fact, it has import. I guess not exactly. And just say module effect is a compiler effect. So then in the main, I will say effect cast compiler effect file included. Okay, I just call the continuation immediately, right? Continue. This is effect deep continue, right? Like that. So which means that like we don't need to do anything there by default. But if I do this in the language server, then the language server can save it. So LSP project. So whenever I process project, I will be handling the things from the compiler, right? Yeah. Process file is this. Like I don't even need to process the file, right? I just going to compile all the things, all the files. Like the compiler is actually only being invoked over here. We also have the parser. Yeah. Maybe like instead of doing it this here, process file should just try to compile it, and then we'll also have the same effect for the parser. Decribe, hello. I'm doing good. Slowly making progress here. Writing my programming language. Process file. I just need to like save I just need to save the thing. Yeah, so I process file here, right? Once again. Or what? I process project. Global. Oh, global is like global state. Yeah. I feel like I needed the file state to be aware maybe of. Wait, do I even need to be aware? I don't need to be aware of anything global actually. Never mind. Right? I think never mind. We don't need that. What do I need though? So in a workspace, I need to know about every file state, right? Workspace state, process project option. This is roots. I don't care about that actually, I think. I think we just need to have mutable files. So like all the files in the workspace is just going to be a string map into a file state like that. I think that's all that I need. So whenever I process a file, right, like this is processing the project.ks. And then I also process all the things, right? Processed files. So let's say when I process project, I want to be able to read the file, and I also know how like handle processed, which is going to be the path into file state into unit, right? So I want over here when I have processed successfully the project.ks, I want to handle processed project.ks. With process project.ks like that, and then over here when I have processed that, we'll say processed is this. I return processed, but then I also handle processed path processed. There you go. So now whenever I want to process the file here, this is missing the files. Files is a reference to files, sure, because I'm just initializing it here, right? I'm going to say that files is a reference to string map empty, and over here handle processed. So I will say that handle processed path and processed is going to be files equal string map add to the path processed to the files like that. Okay, and then over here when I want to handle processed, yeah, so I want handle processed, I will just update the existing processed, right? This means that I will keep the old processed state though. Maybe it's fine, I don't know. Actually, hold on. Workspace files. Yeah, I'm just going to have process workspace files. Is files. Because I'm doing everything from scratch anyway. I'm going to reinitialize it to be empty, and then handle processed path processed is going to be equal to workspace files string map add path processed space files like that. Okay, and then this should compile. Okay, and now So I have update file. That should give me file state option. I should not update the file. I should instead try to find the file, I think, right? So this should return, this should actually return a unit. Update file is just doing something. It's not a part of the state, then it like, yeah, part of, yeah, whatever. Okay. So I will have another thing which is called like file state. So we have the global state, and I want to find the state for the specific URI. LSP URI, right? And this will give me the file state. File state option, because it's not necessarily there. Project, find file state. Like this. I'm going to copy paste that. And then if we have a workspace and the path, I'm going to say string map find opt path in workspace files. That's all that I need to do here. And now we need to, whenever I'm calling update file in the actual language server, right? I'm not going to ignore this. This already returns unit. Okay. So processing should not be used anymore. Processing should no longer be used anymore. I'm going to get this. Oh, we have notify back send diagnostics. Really? That's how the diagnostics work. Okay, so the idea is that now I'm going, yeah, so like this processing, the old processing is going to be completely removed. I'm going to remove this. Delete. Now nothing will work. I will say not processing. I mean, I will just call project to be processing, because now I'm processing the entire project. Right? Everything compiles. Nice. Okay. So I don't have buffers. I will not have this per document anymore. We just have the global state. So processing global state is what I will have here. So I'm going to initialize the workspace folder here, right? And we're going to say that new state. So yeah, I will just say that new state is going to be processing file state for elf get state and the URI, right? Like that. This is my new state. The buffers are not there. Diagnostics get new state. This one is option, yes. So I will say that let's match new state with, and diagnostics is returning what, a list? Okay. I guess over here I'm going to match new state with some new state, and then we do that. But if it's none, then I'm going to have the empty list. So like we have no diagnostics. Right? when the buffer did close, I'm not going to remove anything from this hash table. I'm going to ignore that completely. Inlay hint range. Return. So it's no longer hash table find, right? So yeah, I need to like and to match processing file state self get state match. Let's say self file state for the URI. That is some file state. Then I want to say file state into inlay hints get. If it's none, then I want to return none. Null, I switched to AIO, so like this can actually be deleted completely. So I just want the file state. File state for the URI. Like that. Method private file state for URI is that. Okay, so this instead of that we say self file state for URI. But this one is optional. This one is optional. Let's get rid of these. Actually, instead of lineal IO return, we can just do that now too. I think I just can just do let star file state is self file state URI, and then we just do that. There we go. And that, and this, and then file state to that, and then this. This is supposed to return the list. Get rams. Empty list, I guess. Request format. Also returns, this one returns list option, so that's fine. Just do that. So over here returns option. We just do that. So here returns option. We just do that. Workspace edit T on the rename. Like that. Prepare rename. As an option. Like this. Okay, there we go. Everything compiles. No, not everything compiles. Over here, cast JavaScript. Oh shit, the JavaScript. What do we do about the JavaScript here? Cast processing process file. We cannot process file anymore. You know what? I'm just going to say that process file is going to say. I'm going to raise fail to do here. Something like that. Okay. So should this work now? It should not. I forgot something for sure. To restart cast language server. Looks like it didn't crash yet, at least. Let's see the library. Wait, hold on. I have the autocompletion here. But if I go to the IO mod RNG, this one does not work. This one does not work, which makes sense because I didn't handle the thing. That makes sense. I think the included files don't work. What about the example? I think examples also are not going to have any. Yeah, examples are also not have the highlights because but project case has the highlight. Okay, because example start KS is actually a file that doesn't exist, right? This was supposed to be a glob. Let's let me try if I say here examples hello KS, for example, right? If I do this and if I go to hello, do I need to restart cast language server here? Yeah, so if I restart the cast language server here, I actually do have the thing, but only in this file, right? In the other files I don't, right? Okay, that makes sense because it's listed here. Why does it not work if I just rename though? So if I just rename, then we are going to do what? We are going to do what? Because it's not there in the virtual file system. That's why. I think that's why. LSP processing. So whenever I have updated a file which is project KS, right? It was updated as part of the project. We can see it in the output probably, right? I can try this over here. Yeah, so I have saved the file. So I have updated project KS as part of this workspace. Right? Yeah. Yeah. But then, so I try to process the project here, and the read file is just reading the file system, which is the virtual file system. But I have only written this file there, right? The other files don't exist, but they should exist. So I think whenever the compiler is trying to read a file, we should also like record that in the virtual file system. That way I don't like record the entire directory because we have like a bunch of useless stuff here that should be ignored. So only the files that actually the compiler is trying to read should be recorded in the virtual file system. Wait, but shouldn't this throw an exception? Shouldn't it throw an exception or something? Shouldn't it throw an exception? Oh, because I'm catching all the exceptions and return none. There you go. That's why. So I'm throwing all of the exceptions. Let's at least log it. Log error. Print exception. Print. What is AB here? Print exception print applies a function to X and returns the result. If the evaluation raises an exception, the name of the exception is printed on the standard error output, and the exception is raised again. Yes. This is just uncaught exception and toString. Oh yeah, we just have a print exception to string, and there's toString default. Okay, we just say toString exception. Right, and this is going to be log error. Like that. Checked error. Like this. Can I do that? Restart cast language server. Output. So then I will try to update this. Yep, so we have the error not found. Not found because the virtual file system is trying to find it and it's not doing it, right? Yeah. I feel like also in my processing here, when I try to read file, I will try like contents. Let's do something like try with any exception. I will just fail saying cannot read path, like that. Like yeah, that makes sense. From the virtual file system, because there's like different exceptions there. I mean, I can handle the exceptions that this throws, right? This throws two exceptions. They're not found or like must be a directory, which is just a failure, like that. Right? Yeah, so if I catch a failure S, then cannot read path because of S, right? And if it is not found, fail. This not found path, right? Sure, let's do that. More detailed errors. Okay, so now once again, if I restart cast language server, if I go to project and I press space here in the output, we'll see yeah, it says error standard library is not found, right? That's why. That's what happens. Cast language server has crashed. Oh wait, this one actually crashes? Wait, what? Why does this crash? That makes no sense. This read file is used over here, which I am surrounding with try catch, so this failure is going to be just printed and return none, right? Oh wait, it's because I have registered the toString. Okay. Print exception, register printer. I want this. Because over here I'm having exit 1, but this should not be it, right? I don't want to exit 1 here. Printer is the way to print. The printer should return none or raise an exception if it doesn't know how to convert. Yeah, it's like it's always trying to convert it to a string is the thing. But this was meant to like how do I handle unhandled exceptions, right? Set I can call exception handler. But set uncalled exception handler is not going to use the is going to overwrite it, right? I'm assuming. If I remove that, then we're going to lose the colors in the terminal. I'll figure that out. We need to convert this to a string here. Some make string. Some f format string formatter format flash formatter. There you go. So if I go to project and I try to do that in the output, can I clear this output? Okay, there we go. Standard library not found. Yeah, and then we don't actually crash. Good. Alright, so in order for it to be found, we need to record the fact that a file was actually read, right? So when I initialize the workspace and I'm reading a file, right, I need to also say that the VFS over here is VFS. So let VFS ref is ref to that, right? This language is stupid. VFST. There we go. Like, I really hate the fact that OCaml infers the type of the records based on the names and not based on the types that I give it. That's the stupidest thing ever. Okay, so whenever I read a file, I have the contents here, and I'm going to say that VFS is VFS write file to the VFS. The path is path, and I'm going to write to the contents to it. Like that. And then, so like, yeah, and then this should work. Although, and then we should also, and then this read file should be used for actually reading like the imports and stuff. Yeah, that makes sense. But this should already kind of work probably. If I restart cast language server right now, if I go to projects over here, we have stuff. If I go to examples, hello. If I go to examples, hello, then I have the hover information here. If I go to guess a number, then I don't. But if I add over here examples, guess a number, like that, and I go here, it doesn't work. Oh, it doesn't work. Right. Because, okay, this is a new file. And this new file is not there. Okay, wait, hold on. Maybe oh yeah, because this file was never actually opened, so it was never recorded to the VFS. That's right. So actually, when I read the file, I read it either from the I read it either from the virtual file system. I read it either from the virtual file system, or I read it from the actual file system. And I should, yeah, and then like from the virtual file system, it should be removed if I close the file in the VS Code too, right? So the virtual file system is only the files that I'm actually currently actively working with. The other files should be read from the normal file system, right? I think. Let's see here. If we have an exception here because it could not be read, which means that this try should be over here instead. Right? So we don't do this actually. We instead say that if there was an exception, then I'm going to try to read the file from the file system. Read file from file system. Can I have that extracted? Then I don't need to record the files into the virtual file system here technically, right? Only those that I have opened is what I should. Yeah, interesting. So over here, let contents is read from file system path. And this is like read from system path, is that? And then if over here, what I need to do, if we have an exception, we're going to actually read from file system. The path, but path is now going to actually be workspace root lsp URI sp URI to path and path. They need to be concatenated. That's right. There, because that, like, this path is virtual path. This path is the real path now. Okay, let's try again. Does this work? Restart language server. This works. Guess a number. So guess a number has the completion here. If I remove this from the thing, then I will lose the completion because this is no longer processed file. If I add here examples 0 ks, right? Then we should be able to go into the 0. And no, this does not work. Why does this not work? Output. System error. Because I said example. It should be examples, that's why. 0. There you go. So now I can just change the project file and I change the files that need to be like highlighted. All right, good. We can start with that. I will do like the actual processing like of the globs here later, I guess. Just list all the files explicitly here. We have example, we have a guess, a number, We have a hello, we have import 0, and we have a test interpreter, right? And then we have the standard library. Okay. Trailing comma. Sure. So now I should have the highlighting in all of these files. But if I go to the standard library, because standard library works, okay, good. If I go to the file that is included, like RNG, this over here does not have the thing, right? Because now I should say, I should handle the thing, right? Yeah, I should handle the thing. So when I'm doing process the project, I should handle the effect of the compiler, which is including the included file, right? Process file, process project, roots. Not even here, right? Process project is being called here, where we have files, handle processed. Oh, we have handle processed there, right? Yeah, we have handle processed, that's fine. Yeah. So I think I'm just going to like try with the entire thing, right? So if I have the effect compiler effect, where's the auto completion? This stupid OCaml language server is so bad. Compiler file included. I'm going to continue. Okay. Fact deep continue. All right, so this thing over here has is of type processed file, which has the roots. No, it's not. That's the incorrect definition, stupid OCaml. Okay. S. Included. Okay, there we go. This is what we want. No, this is not it. File included. We can go to the definition here. File included. Right, so we have path, AST kind compiled. Yeah, let's see. Path, AST kind and compiled. Right, we have this. So this path. Yeah, this path. Let's see. Log info. Project file included. Path. Right. I want to just log this. This is what though? This is a path. I can say path print path, right? I just want to see. If I say restart cast language server, we should see it immediately here. Yeah, so we have file included, stdio mod, stdrng mod. There you go. These ones are special though, right? These are special files. These are special files. So this is not like the real path that I want here. How do I handle that? How do I handle that? Let me just commit. Progress on multi-file LSP. I just want to do what? The like what's the way I'm reading the files, right? I have this source read, right? We have special files like std because it potentially is embedded in the binary, right? It's potentially embedded in the binary, and this is special. But the path, this over here, right? Yeah, I feel like we only need the path. Yeah, I feel like we only need the path here. So yeah, this right now, when I'm reading a file, I'm always reading from the actual file system. But that should not be the case, right? That should not be the case. I should actually do the effect here, which is reading a file, right? So I should have another effect, which is, so this is a read special. A read special under the hood is going to read a normal file. So we'll just have the effect read, which takes the path, and reads it. Right? I think so. So this over here will also be done through the effect form read path. So the cast binary is going to handle effect source the cast binary is going to have the effect source read path to be read from file system. Let's have read from file system, like maybe like in the standard library. I'm surprised they don't have function like that in the OCaml standard library. Let's have it here. So yeah, if I read, then I will just and we have continuation, and we're going to just continue. Act deep continuation with reading from file system path, right? Okay. But if I'm trying to read from inside the LSP, we're going to actually use the provided read file thing, right? So we can actually handle the changed files from the virtual file system. Okay. LSP over here, right? Process project read file. Yes, over here we have the same thing. Going to handle the this effect. So this should be not read from file system, but actually like just read file. Oh wait, but read file gives me the URI here. As a result, right? So I just want to read file path dot contents, I guess. Okay, sure. But then if the, so now if the file is included, so now if the file is included, the path, what is going to be the path? Yeah, like I still am in like this special file path. Like, okay. How do I handle this? How do I handle this? Path is potentially the special one, right? I think I want to be able to have a map. Maybe like I have the read special. And maybe this should not be there. Read special is just reading it, but maybe instead of reading the special, well, I mean, read special. I feel like read special should give me potentially like the actual file name on the file system if it was there. File included in the core syntax, right? This is over here. I'm performing the file included. This path is a path, which might be a special because it says like std, because std is special. But std should not be special. In case, yeah, I think like I think that is the thing. std should not be special if I'm running it locally, like, and not in the browser, right? It actually should not be special. But we have special std lib over here in the cast compiler. It is hard coded. Over here in the default. And the default is being used in multiple places when I'm creating the compiler. Maybe this should be like the effect. Maybe I should say like the effect, like what should be the path to the standard library. Right? I should like figure out what this path to the standard library is. Default. I mean, I can just pass it over there, but then I need to, yeah, I need to like handle that and stuff. Yeah, let's do that through the effect. I like effects. Type effect t plus equal find std. So find std should be a unit, should be just a path. So like find std just gives me the path, right? Like that. Did you start from scratch using a camel? Yes. Hello. It has been like, I don't know how long ago, like 2 weeks ago already. This time I'm focusing on the language server before making the language features. This effect is different effect than that effect. And I cannot, like, if I shadow it like this, it's annoying. I cannot. Yeah, I mean, okay, sure. So yeah, over here for the default one, I will actually say. Oh wait, hold on. Yeah. Let's just say that this stuff is going to be here. These are all the effects of the compiler. We want to find std. So we have include the file. We can find std. Yeah. So this over here should not be special stdlib. It should be effect perform effect, which is now needs to go higher up. Should be effect dot find std, right? Like this. Effect, and this effect is a different effect. Oh my god. Can I call the can I say stdlib dot effect? Oh, I can do that. Okay, nice. That works. Okay. This is now not going to work, right? Cast eval project. It's going to say that we have a compiler find std is not there. So find std is different based on if I'm in the binary over here. So this is going to say that if I try to have cast compiler effect find std, if I'm trying to find std, then I'm going to continue with the file. Which file? std? It kind of like depends actually. Like I feel like I should hard code this. It depends. It depends actually. Like there should also be like the environment variable, by the way, where the standard library. Where does the standard library live? Find std, and then this over here is going to also be path relative to this libks. So std and then libks, like that. Relative imports, yeah. Whoop. The imports only work from regular files. Imports only work from regular files. What does this mean? Span file name. Wait, but it should be a file. Got std. Did I say file std? So like that should be working. Like it's this means that it's a special std. Special rule. Special std. It's not even like there. Imports only work from regular files. There's an error. Span. Where's my span? My span is not here. What? Message span. Shouldn't this be there? At std1. Wait, what? What? At std line 1 column 1. Well, what? What? It's because it's when I'm importing the standard library, right? So cast compiler default over here, the bootstrap. We have span fake std. Maybe this is the one, right? File name is special s. That's right. Yeah. Because I'm importing from the fake std. That's right. Import span Span file name, so it's relative. Match path. Relative paths. Import. Oh, because this was supposed to be a special one. I see. Yeah, yeah. Yeah. So okay, that makes sense. That makes sense. If it's not relative, wait, but it's path is a file. It's not supposed to be relative here, right? Log info trying to import path print path. What's happening there? Trying to import .libks. That's wrong. Relative to file name concat. Oh, because dear. Okay, I understand now. Because it's relative to. That's not that. I need actually path concat. Relative to is relative to the file, not to the directory. Okay. Let's see. Concat path and relative. Match path. If it's path, and I don't do the dir name. I just concat path and relative. And if it's this, I don't need the directory. If it's just special path, I'm just saying special path and relative, like that. Right? That's what I want. Concat and relative to is different. Okay, so now I'm trying to import stdlib, and this is not a relative one. This is not a relative one. So if it's an absolute path, if it's an absolute path, it should be just file path. Like, I should be able to support that, right? Just file path. Like, why should I not be able to import the absolute files? Okay, there we go. Maniac, hello, hello. Okay, that worked. That worked. What doesn't work? What doesn't work? No idea. What was I doing? Cast language server. Okay, does this work? This does not work because output of the cast cannot find the file state for guessing number. File included stdio mod. File included std-rng mod. Find file state for stdlib. Find file state for std-rng. Yes. Is there any errors here? I don't see any errors. Why don't I see? Okay, if I go to the standard library. No, that doesn't work either. I actually don't have, because I have read. Yes. I'm seeing yet another streamer who seems to be using OCaml to create programming language or a DSL. Why is that the case? I don't know OCaml. Just because OCaml is not special. Actually, I don't like OCaml too much. The reason I use it is because Rust is compiling too slowly. Which, I don't know. OCaml is okay. It's not like Like the languages that I consider, there are just 3 languages that I would consider for this project. There's OCaml, Rust, and Haskell. And out of those 3, OCaml just gives me basically instant compilation, right? But as a language, I think Rust is a better language, and I think Haskell is a better language than OCaml. So technically, I would write in those if but I feel like I want a faster like iteration. Zig? No, not Zig. Zig is terrible, in my opinion. If you like it, then sure. But it's too low level. I want a high level language. Having the ability to go low level is good. So like I'm like Rust is not only low level. Rust is both low level and high level. That's what I care about the high level part of Rust. When I use EIO and EIO COTTP, my OCaml compile speed is not much faster than with Rust. I'm not using any libraries. I am using EIO though. I am using EIO for the LSP, but that's like on one of the things. Like in general, the LSP is the only thing that's using it, and it's pretty quick. I don't think it's going to go much further. I'm not going to use EIO. Maybe. Like I'm going to try not to use it much. But wait, but why does it compile slower? It does make sense. Or is it specifically the EIO COTTP? Say EIO multiple times since you're speaking Spanish. Why would it be compiling slower though? As far as I understand, one of the reasons OCaml is really fast is so like you don't need to run. You don't need to like find the implementations for traits, for example. I don't know if that takes a lot of time in Rust or OCaml, but in Rust or Haskell, but like resolving the like finding the concrete implementation of a trait is not like really trivial, maybe, right? OCaml doesn't do that. If a function is polymorphic, then it's polymorphic over any type. There is no type constraints that need to be like checked. And as far as I understand, OCaml also doesn't really need monomorphization, which makes it compile really fast as a result. Like, is your project open source or something? You say it's slow, not much faster than with Rust. Well, I mean, my Rust was compiled for a minute. Every like the debug build was compiled for a minute. I don't know if that's if it's that, but it's the biggest dependency you have. It's 1 to 5 seconds of compile time, and for your Rust is like 2 to 15 seconds. But the file difference is not that big in your daily usage. Like if you do it from, you mean like the build from scratch, or like incremental build? Like because your project specifically is like, because you don't really compile the dependency every time, right? I don't know. How big is your project? I'm wondering if I'm going to hit the issues with OCaml, but if that is the case, then maybe like going to OCaml wasn't worth it. I have so far 6,000 lines of OCaml in this, which is like nothing, of course. If I try to do the build from scratch, I mean, even like this is also like not really from scratch, right? This was what? Let's see, Dune clean and time Dune build, right? If I do it completely from scratch, then it right now takes... There we go. It's not that fast, indeed. This takes 10 seconds. No, it takes... Oh, wait, this was 30 seconds? 10 seconds of CPU time, right? It's tiny, 2-3 files at most. Wait, so you have a tiny project that compiles slowly? The Rust project is much bigger, like 6 crates organized as a workspace with like 30-40 files in total and maybe dependencies on C bindings. I see. All right. Well, we'll see if I'm going to hit the issue. But according to the internet, OCaml is supposed to be really fast to compile. Rust is pretty slow, and Haskell is like even slower. Especially if you do like type level stuff, type level programming a lot, right? Which I am doing. So yeah. And also I wasn't splitting my Rust crate into multiple crates, but doing that also would require basically a rewrite anyway, so I don't know. Okay, what's happening? We cannot find the state. What was I doing? Processing. Processing. Workspace files. Handle processed. Handle process project. Handle processed. We have processed this file. Hello, Nerdzel. Rust is supposed to be slow, but I use both and allow both, and I'm not struggling with completion times in either. Just they're both slower than when I use Go. Oh, okay. Okay. No, Rust is pretty fast to compile on small projects too. Like even like I'm working on the game, right? Over there that was just linked by the bot. That was also written in Rust, and that is compiling faster, like at least twice as fast as my programming language, even although the amount of code is the same. So like both of these projects, the game and the programming language, the previous version that was written in Rust, are about 20,000 lines of code. But the game was compiling a lot faster. I was just doing something that I'm not supposed to be doing in Rust, I guess. Maybe I was unwrapping too much, I don't know. I mean, it's not unwrapping. I was using like a lot of async code, a lot of generic code, and not splitting the crate. Using collab as a CLI blows the compilation and binary size. It was I was doing the profiling. It was type checking of my crate, which was taking 20 seconds. Pure 20 seconds that just for type checking my crate. So it's not like the procedural macros. It's before the code gen. And everything. You write async free using operating system threads. Yeah, like if you yeah sure. I just like async, and like I'm already I feel like I'm going to abuse the effects in the OCaml too. Similarly to like that's basically allows me to do the async stuff in OCaml, right? Yeah, that's how EIO is working under the hood. Not sure if I will do it with EIO or like my own runtime for async, which basically how it was in Rust. I was building my own async executor, basically. Small one. All right, let's see. I need something. We have file included, we have file processed. I want something like this. Processed, process file, handle processed. I want to say over here log info project file processed path. Let's do that. Restart cast language server output of this. Hello? Cast language server. Okay. Wait, hold on. I'm not even getting there. Oh, this is the project roots. No. This should not be here. Process project. Handle processed. It's in two places, right? Over here. Okay, so yeah, so there we go. See, we have file processed project KS. Okay. Wait, does this mean that I have the autocompletion in the project KS? Let's see. Yeah, I do. I do have that. But it doesn't have the autocompletion, the like the LSP is not working in this file, right? Why not? It was also processing the standard library. The files were included. And then what? Like, maybe I had a cast run stdlib. No, this works, right? The standard library is successfully working. If I try to evaluate examples, import 0, that works. Okay, like, I mean, that works, right? And if that works, then what doesn't work? I need to debug further. Read file, handle processed, no, I need workspace, I need process project over here, right? I want... you don't get how effects in OCaml are efficient. If they somehow go up the stack and find a matching handler, they look weird to me. They are just exceptions, but resumable, right? Like, do you understand how exceptions work in OCaml? It's the same, but at the same time, it's like going up the stack, you also capture the continuation. That's like the only difference. This continuation object here. It's implemented in the runtime of OCaml, right? The efficient capturing of the continuation, which basically, like, there are different ways to do this. One of the ways is you can rewrite your entire program into the continuation passing style. That's what the JavaScript of OCaml doing, I think, to transpile to JavaScript. Project roots, string list, log info, roots, project roots is list print string print project roots. Restart cast language server. Take a look at the output. Project roots. These are my project roots. Okay, yes, so this has been parsed successfully. And handle processed. And then we try to process these files. Right? So we go for these roots, right? So I'm trying to process the stdlib. We have included the things. And then it just stops. Why does it stop here? That makes no sense. I don't get it here. Why do I stop? Log info start. Log info end. Path. Restart output. Okay, so I start processing the standard library and then I never finish. All right. Why do I never finish? Is that because of the effects now? Do I have some exception with underscore? With exception log info. This is the virtual file system. I don't think I care about this. It's not the one. Yeah, we do this process project with underscore into none. Let's have over here exception, and we will return none, but I want to log error. Print exception, print exception. Right. Error file processing. Like that. Print exception to string. Start language server. Output. Root. Error while processing. System error. There you go. There you go. So now, yeah. Okay. Home Kubernetes projects. Cast, and then we do home projects again, right? So there you go. We have I have a file which I'm trying to make relative to this thing. Wait, what does this mean? Where, why, when am I trying to read this file? The stdio mod. It happens when I have included the file, right? But I have already included the file, which means that I have actually processed it and compiled successfully. So yeah, this file doesn't exist, which makes sense because I'm trying to edit relative to the workspace root, but it's already an absolute path. Oh, I know why. I think I know why. File included. This is when a file has already been included. Like that's the weird part of it here. File included. This, yes. And we have the full file for some reason. Why? Why? So in order to debug this, I need to catch exceptions in more places. So I'm trying to process this thing. Okay, let's see where file included has been performed, the effect over here, right? Effect perform. So I have included the thing successfully. So it shouldn't even try to go into this file again at all, right? Like it has already read the thing, right? I have already read the file, yeah? Maybe like hold on, maybe read file over here. How about that? Try with with exception. We will erase the exception. But I'm just going to say log error. Couldn't read path. Like that. Yes. Okay. So someone is saying read the file, this thing. Right? Someone is saying read this full file. Okay. Who is saying read the file? Read file. Read file is being like over here in the source read, right? Let's do over here, try with here. Is this where I'm failing? Yes, that is where I'm failing. So, yep. Yep, source read. Source dot read. Okay, this happen. Does this happen in the LSP maybe? LSP does not do that actually. No. So it's probably in where? Read special. Source read special. Let me do that. Is OCaml the best choice for creating DSL programming language? Rust seems to have been originally created using OCaml. That's a question. I don't know if it is. It's an okay choice. You can try using Rust instead. I was making this language in Rust, but then I started rewriting it in OCaml. That the only reason is the compilation times. So technically, I could have continued using Rust. I think Rust is a better language to do that. Or Haskell is a better language than OCaml, but I want to work quicker. So I want the faster compilation times. Otherwise, I would choose Rust instead. What are you making? It also, I mean, the language choice doesn't matter too much, though. Like, just use whatever you are used to. That's where you're going to be most productive. But I mean, OCaml is a simple language. If you don't know Rust, then learning Rust will take more time than just writing your thing in OCaml, probably. Because OCaml is a simple language. How to debug, guys? How to debug? Is there a debugger for OCaml? Is there a debugger for OCaml? Can I read this stack trace? Can I write this stack trace over here when I'm saying that file cannot be read, right? Couldn't read this. Can I say print exception, print backtrace? Print backtrace to the std_error. Can I do that? Couldn't read. Yeah, so there we go. It is stdlib, read from file system, or read file. That's not the full stack trace. It's just saying that is over here. Read from file system path. I want to know where this was called. This is not the top level function. The OCaml backtraces don't include any information. I hate it. Don't use OCaml to write your thing. There is no way you can debug this. The stack traces don't include all of the lines that are relevant. You hate it? You okay? Yeah, I'm okay. I hate everything. I'm fine. It means that I love it. Okay, hold on. So read from file system over here. I mean, that makes sense, right? So I'm trying to read a file, which is like, for some reason, the absolute path. Why is anyone giving it the absolute path? So let's see the logic here again. I'm initializing the workspace. I have the root. Root is going to be converted to the path. So I'm converting this root path. Right. But so yeah, I'm concatenating the root path to the path, but this path is for some reason already absolute. Why is it already absolute? Because that makes no sense. Right? This function should be called with relative paths. Right? Yeah. That's what I should do. I should say that if path starts with slash, then I should fail saying must read relative path. So who is doing that? Must read relative path. Beautiful. And no stack trace. Because error while processing. Error while processing. Maybe over here. Print exception. Print backtrace to the std_error. Let's do that. So that I see the thing. Output. Error while processing must read a relative path. There is no backtrace that was printed. Error while processing. Why does print backtrace don't print anything? Why does print backtrace don't print anything? I hate this. There is no backtrace. I say print backtrace, it's not printing backtrace. Raise exception. Let's re-raise the exception, maybe then it will tell me something. Okay. This gives me some stack trace. That's what I expected to see there, right? Read file, process, list map, processing init. On request initialize. Okay, processing init. Okay. Call from linol EIO catch. Okay, this thing is also catching something. Raised from fail in file std source std lib. Okay. Read file. Process project. Read file. This stack trace is useless. This stack trace is useless. Hold on. I have just done nothing for the last 30 minutes. I've been just staring at this, not knowing how to debug OCaml. Is that a skill issue? Or is that the OCaml issue, that it's not printing the stack trace properly? Like, who is calling read file? Why don't I have this information? The reason I know why. It's because of the tail calls. We have the tail calls in OCaml, so it is not having the things. Can you show me your theme? What theme? Of the editor? I'm using OneDark. Read file is being used from over here, the source read. Source read. Once again, source read. Highlight CLI. This doesn't matter. Interpreter CLI doesn't matter. CLI doesn't matter. Compiler, core syntax. This over here. This does matter. This does matter, but this already has worked successfully, right? Let me see here. Log info. Successfully read. Path, print path. Right? Let's see that. No? Restarting cast language server doesn't restart anymore? Is that because of what? Because it crashed, so it refuses to restart now? We need to reload the entire window? Sure. OneDark by? OneDark. That's not the one. Which one do I have installed? OneDark Pro by Atom. Binarify. Over here. Down. Copy link. Output. Cast language server is not opened. Project KS. Cast language server. Alright. Read file. So we have successfully read. Yeah, see, I have successfully read stdio mod. I have successfully read, right? Like, I already have known this, right? And then fail. Wait. What is this raised? At print exception in the LSP. Over here. Yes. That's why. I have like this thing. I should exception. I should log error. Project error while processing. Exception to string exception. Did I have that before? I removed it on accident, probably. While processing, must read relative path. Relative path. Got a path, right? So once again, that start cast language server cast. It says must be relative path, but we got this, and this is not an absolute. This is an absolute path. So who is reading this? Who is reading the IO mod? Who is reading this? Why can't I even find that? Oh, because it's underscore mod. Underscore mod. Okay, like this is literally only listed in this place, in this single place. I have where I try to include a thing, and I have already included it successfully. I have successfully read it already. If I have read it already, why would I do that again? Who is trying to do that? This makes no sense to me. Can I stop wasting time somehow? Log info. Handling source read. Path.
Hello, Gorley.
Hi, Pigorly. Yeah, I'm handling source read. This. I am handling source read that. Source read. This. When I'm trying to call this function is being called in some CLIs, which don't matter, in the core syntax over here, when I'm trying to read the thing, but I have done that successfully. Wait, hold on. Let's okay, fine. Let's do this again. Maybe I'm trying to include it twice for some reason, which should not happen. Okay, trying to read, because that's the only place where this would make sense. And then there's also import, but I'm not importing the file, right? Let's do that too here though. So this is successfully read when importing, reading thing when importing. Okay, like that's the only thing. Like that's literally the only two places. Okay. Yep. Wait, trying to read over here. Yep, that's what's happening. I'm doing it twice. Why am I doing it twice? So the include. So the include is trying to do that. Why? Relative to span file name. Why am I doing this twice? That makes no sense. That's a my bug, I guess.
Ogma, are you still here? I hope you have not left us yet.
Source read. So it means that, hold on, this from, right? Let's do from path print span file name, right? So this means that I'm trying to do that, right? So I'm trying to read when including this from that. Which means that stdlib was trying... Okay, stdlib was trying to be processed as a full file. I think I know. I think I know. I think I know where I made the bug. Processing. Process project. Yeah, it's when I'm processing the root, right? Read the file. Read the file returns red file, which is contains the URI too. I don't care about this URI though. Wait, what am I using this URI for even? Right? So this happens when I'm actually processing the standard library. And that's my thing, right? Because this is... yeah, I should have like the relative file like path, which should be just string. I feel like I should do that. Yes. So source should be, yeah, there we go. Source span should be not that. That's incorrect because now I want this spans to be relative here. Path. Okay, I figured it out. File path. I don't want to use the URI here. I don't. Yes, I don't. This and path. URI is that path. There you go. I think this is going to work now. Okay. Please, first try. No, that did not work. Or did I not restart properly? No. Hold on. Trying to redo it, including this from that. Okay, because I'm processing this file. Yes. Let's see. Processing. Processing. Project processing. Yes. Processing. Over here, this file. I want to save file path here. Actually. To see what's going to happen. Yeah, so I'm processing this full path. Why is this a full path? That makes no sense. So process file is being used in these two places. Project KS. And over here, read file path. This path. It should say start, right? Yes, it's a start stdlib. Why is this not stdlib, but this and stdlib? That makes no sense. Read file. Oh, it makes sense now. It makes sense now. It makes sense. It makes sense. Hold on. Path. Yep. In the other place. Read file. Path. Path is concat. There we go. This should not be that. This should be a relative path. So this should be path is relative path. I should actually rename this to be relative path. Right? That would make sense. Relative path. Read file. Path. There we go. This is the path. Okay. It's going to work now. First try. Okay. Let's take a look. Project KS. We have stuff here. And we go for the hello. And we have the stuff here. So hello has 0 works. Test interpreter works. We have inlay hints. And then go to the standard library. Standard library works. And then standard library IO. This one doesn't work still. So this is the included file, right? This is the file that was included, and for some reason, right? It should say, that file got included. Yeah, and but we cannot find the state for this file, for the IO. But the file was included stdio, right? Because this is a relative path, but we are trying to find the absolute path, probably. Or something like that. Going to work in a second. LSP processing. I'm trying to find, right? When I'm trying to find the file state. I'm trying to find state for this. URI, right? So we're trying to find that. And then we're trying to find in the workspace files this file. Let result is this in result. If result is none, then log error file processed file this path not found. Okay, restart. I want to show though. Not found. Got. I want to like know all of the files that are in the workspace. Workspace files. This is what? This is a string map into string map. List map function key value. Key. Like I only care about the keys here. So this should be something like list print string and restart output. Okay. std IO mod. Okay, process file std IO mod not found. Got these. Yeah, okay, wait, hold on. It actually was not found. What? Okay. 1 second. Which means that the file that is included over here. Oh wait, of course. I didn't actually include it, right? I didn't handle processed file here. So I forgot to write this literally. Handle processed. Handle processed file, which is path, and then the actual processed stuff here. Which is going to be the file state. File state. File state. Right, which has... Why is the autocompletion so horrible in this language? I have no idea. We need to do all of these. We need to do all of these. Okay, parser error. None. Parsed is some AST. Compiler error is none. Typer is none. Compiled is some compiled. But only if I'm going to match kind with expression. Only then we are going to do that. And if it is anything else, then I'm just going to do nothing. AST parsed. File included. Yes. Okay, got it. File included should have not AST, should have a parsed, which is parser result. All right, and then over here This is parsed. Can I do that? I cannot. Like that. Okay, good. Now we go here. Unbound value kind. It's not unbound. There we go. Now I want to handle processed path. But path in this case is just a path. Match path with file path. In other case, return nothing. Oh my god, this is ugly. But it's fine. Parsed is parsed. Okay, and then the URI. What's the URI of a file? That's the only question. Do I even care about the URI of a file, though? Do I even care about the URI of a file here? We'll see where it's used. LSP URI from of path to do. This is not real URI. Okay. Restart language server, go to the stdio mod, and we have the autocompletion here. Okay, I mean, we have the LSP working inside this file now. Okay, nice. So now the LSP is able to see all the files that are reachable from the root over here. Okay, nice. I guess this is not going to work on the in the browser though yet, but it took me too long to do that, so I'm going to not to worry about the browser. And this URI, by the way, let me just see where is this being used. Red file URI. It's not being used. No, over here URI is file URI, because the file state contains the URI. But should it? Is it being used? It is not being used. I think I can remove this. Let me just remove it. Remove the unused stuff. Yep, there we go. If I just remove it like that, then we're not going to have any problems. Restart language server. std rng. There you go. Okay. Now go to definition doesn't really work because it's trying to go to the file stdlib instead of going to the full file, right? Right. Yeah. Yeah. Yeah, the spans are a little weird. Okay. Well, some things work. Some things work. All right. Say pigorli, pigorli. Pigorli, pigorli, pigorli. Pigorli, pigorli, pigorli. Keep saying it. Well, I'm not going to follow the orders from Pigorli. No. No more Pigorli. Pigorli. I'm not going to say Pigorli anymore. Now baby. Yeah, now we go to the baby, but we need to go somewhere. And then I go for the baby. All right, let's see who is doing what. Let's see who is doing what. Making a game from YouTube comments sounds like a great idea, right?
Ben has.
That sounds like a good idea. All right, see you guys next time. Thank you for watching. Bye.